Since the dawn of the new millennium, our planet has been rocked by over 1,700 earthquakes, each registering a magnitude exceeding 5 on the Richter scale. Many of these seismic events have occurred within the infamous Ring of Fire, a volatile zone encircling the Pacific Ocean and significantly impacting North America. But the most looming threat is the San Andreas Fault. This geological scar has the potential to unleash an earthquake of such immense power that it has earned a chilling moniker, the Big One. Imagine the sheer devastation, the unimaginable consequences for California. A terrifying prospect indeed. But the Big One is merely a prelude to an even more catastrophic event predicted by scientists for the year 2030. Whether we like it or not, there's a staggering 70% probability that we will experience an earthquake of at least 6.7 magnitude on the Richter scale. The San Andreas Fault is the prime suspect, but the truly unsettling aspect is our inability to predict the precise timing of this seismic monster. Throughout history, massive earthquakes have struck approximately every century, so we must always be prepared. Let's journey back in time. We can witness the echoes of past seismic disasters, earthquakes that decimated cities like San Francisco and Fort Tejon. Buildings constructed in those bygone eras were never designed to withstand such forces. They crumble, they collapse, and even if they somehow remain standing, entering them after a quake is an invitation to disaster. However, buildings are not the only danger. Downed electrical lines spark and crackle, ruptured gas pipes hiss and threaten to explode. Even a seemingly idyllic hillside residence can become a death trap as the earth beneath transforms into a massive, unstoppable landslide, swallowing everything in its path. Road trips become a distant memory as highways buckle and crumble. Having spare water and food becomes essential as grocery stores become inaccessible. The economic impact of such a disaster would be staggering. Experts estimate that recovery from the Big One could cost the United States upwards of $200 billion. Fortunately, this particular earthquake is unlikely to trigger tsunamis. However, there exists another, even more formidable threat. The Cascadia Subduction Zone, a geological titan that stretches from California all the way to Vancouver, Canada, dwarfs the San Andreas Fault in destructive potential. This zone has the power to obliterate the entire Pacific coastline. Subduction zones, like the Cascadia, are formed when tectonic plates collide, one forced beneath the other in a slow, grinding dance of geological titans. Here, the North American plate grapples with the Juan de Fuca plate. These zones are not to be trifled with. They are terrifying hotbeds of seismic activity, capable of unleashing underwater earthquakes of unimaginable power. But how can an underwater quake affect us on land? The answer is tsunamis. These colossal waves, generated by the displacement of the ocean floor, can surge inland, inundating coastal cities and obliterating everything in their path. While the Ring of Fire is currently the most active seismic region, the Cascadia Subduction Zone remains a sleeping giant, a slumbering beast capable of awakening with devastating force. The last time this immense geological pressure was released was in the year 1700. Unlike the San Andreas Fault, an earthquake along the Cascadia Subduction Zone will unleash massive tsunamis, waves dwarfing anything seen from the San Andreas. If such a quake were to strike, let's hope you are far inland, preferably camping in an open field, because most buildings and bridges along the coast would likely be pulverized. And be prepared for the aftershocks, which will be devastating. Nature herself will not be spared. Landslides will reshape the landscape, forever altering animal habitats and even our own human settlements. But there is a glimmer of hope on the horizon. Scientists are working tirelessly to mitigate the potential damage, implementing new building codes that require structures to withstand immense seismic forces. Modern warning systems are being developed, and all new infrastructure must adhere to strict earthquake-resistant guidelines. The Juan de Fuca and North American plates are currently locked, but this tension cannot last forever. When they finally break free, prepare for a cataclysmic jolt. The closer you are to the epicenter, the more intense the shaking and the greater the damage you will experience. But even those fortunate enough to be far away may still feel the ground trembling for an extended period. Consider the comparison between the Cascadia Subduction Zone and the San Andreas Fault. In 1994, the Northridge earthquake, a 6.7 magnitude event near the San Andreas Fault, caused immense destruction. Sadly, many lives were lost, and countless people were injured. Buildings constructed before modern seismic codes were particularly vulnerable. Now, imagine the Cascadia Subduction Zone unleashing its full potential, a magnitude 9 earthquake. A magnitude 6 earthquake releases the energy equivalent to approximately 44 million pounds of dynamite. A magnitude 9 earthquake unleashes a staggering 44 trillion pounds of dynamite. The most powerful earthquake ever recorded struck Chile, registering a magnitude of 9.5, and it devastated everything in its path. So, imagine you have somehow survived the initial earthquake from the Cascadia Subduction Zone. The ordeal is far from over. Soon after, a massive tsunami will strike, with waves potentially reaching heights of up to 100 feet in some areas. Imagine a strange purple glow in the night sky, something scientists initially dismissed as a joke, nicknaming it Steve. But this was no laughing matter. They soon gave it a more fitting scientific title: Strong Thermal Emission Velocity Enhancement, or STEVE for short. This Steve is a fast-moving river of superheated gas, perpetually flowing westward, and only making its grand appearance before midnight. But what if something similar occurred after midnight, a mirror image moving in the opposite direction? Now, scientists believe they've found Steve's counterpart, the anti-Steve, hidden within data from a Norwegian research station. Back in December 2021, their instruments captured a brilliant purple streak, stretching an astounding 620 miles across the sky. Unlike Steve, this phenomenon only emerged after midnight. Satellites from the European Space Agency, monitoring the atmospheric conditions, confirmed that ions were indeed rushing eastward. While Steve's nocturnal twin remains officially unnamed, wouldn't SAM, short for Steve After Midnight, be a fitting moniker? Let's picture a sunny day, the sky a pristine blue, yet snow is falling. Not just any snow, but diamond dust. This is a rare and beautiful weather phenomenon where millions of microscopic ice crystals form near the ground. These tiny crystals, suspended in the air, catch the sunlight and explode in a dazzling display, sparkling like a shower of diamonds. Unlike conventional snowfall, diamond dust can descend from a cloudless sky, earning it the alias clear sky precipitation. This spectacle is a result of temperature inversion. Normally, air temperature decreases with altitude, but during an inversion, a layer of cold air becomes trapped near the ground, with warmer air sitting above. This warmer air holds more water vapor, and when it mingles with the frigid air below, it transforms directly into ice crystals. For diamond dust to form, the ground-level air must be incredibly cold, far below freezing. These ethereal ice crystals can fall for days, but because of their feather-light weight, they rarely accumulate like regular snow. Next, we encounter the fall streak hole, also known as a hole punch cloud. Imagine a vast expanse of cloud cover suddenly pierced by a large circular or oval-shaped void. These clouds, typically found at high altitudes, are composed of supercooled water droplets. Water that remains liquid even below freezing. These droplets are just waiting for a catalyst to freeze, and ice crystals provide that trigger. When an aircraft passes through the cloud, it can introduce ice crystals. Once present, these crystals rapidly freeze the surrounding supercooled droplets. As these droplets freeze, they grow heavier and begin to fall, creating a hole in the cloud layer. The process continues as more and more droplets freeze, causing the hole to expand outwards. A tornado is a terrifying force of nature, but a fire tornado elevates the horror to unimaginable levels. These are colossal rotating columns of fire and ash, born from a confluence of extreme heat, powerful winds, and uneven terrain. The intense heat of the fire generates rapidly rising hot air. This creates a vacuum, drawing in cooler air from all directions, resulting in powerful swirling winds. When winds from different directions collide, they force the fire to spin, creating a vortex similar to a tornado. The fire tornado intensifies, creating its own localized weather system, sucking in flames, ash, dirt, and anything else in its path. Wind speeds can exceed a staggering 140 mph, and these infernos can rage for upwards of 20 minutes. Picture this. You announce your travel plans to Tristan da Cunha, and your friends stare back blankly. Chances are they've never even heard of it. That's because Tristan da Cunha holds the title of the most remote inhabited archipelago on Earth. The nearest inhabited land, St. Helena, lies approximately 500 miles away. A mere 229 people call Tristan da Cunha home. In such a tightly knit community, everyone is connected. Cousins, uncles, friends, all intimately familiar with each other. Remarkably, only 10 surnames exist on the island, representing just 10 founding families. Reaching this isolated haven is an adventure in itself. There's no airport, so your journey will be primarily by sea. The voyage from South Africa typically takes 5 to 6 days. Only 3 ships regularly service the island, making fewer than a dozen trips annually. Some cruise lines might include Tristan da Cunha in their itineraries, but travel arrangements must be made far in advance due to limited cabin availability. You'll also need landing permission. While Tristan da Cunha lacks traditional hotels, several guest houses offer accommodation, and you might even have the opportunity to stay with a local family. They provide a place to sleep, 3 meals a day, and laundry services. An impressive 88% of your payment goes directly to the host family, with only 12% allocated for taxes. Imagine traveling to a remote corner of the earth, a speck of land lost in the vastness of the ocean. We find ourselves on St. Helena, a British overseas territory. Here, surprisingly, a full board stay can be quite affordable, costing around $65 in 2024. Yes, the island uses sterling, a testament to its British connection. But there's also a local currency, the St. Helena pound, pegged at parity with sterling. Interestingly, it's only been about 80 years since St. Helena started using actual money. Back in 1942, the naval station began paying wages in cash, a pivotal moment. This shift propelled the islanders from a barter economy into a cash-based system, allowing them the novel experience of making their first cash purchases. A word of advice: pack everything you might need before you embark on this journey. Don't expect to find a Walmart here. While there is a supermarket, it's a far cry from the sprawling emporiums you might be used to, with their seemingly endless aisles of oversized mayonnaise jars. Tristan's Island Store, as it's often called, lacks plate glass windows and flashy advertising. To be honest, it resembles an abandoned barn from the outside. Yet this humble store plays a vital role, providing essential goods that complement the locally produced foods and wools. If a resident needs to buy something, they must place their orders months in advance, awaiting the arrival of incoming ships. The store operates from Monday to Friday, serving as a lifeline for the community. Today, the islanders continue to cultivate their own crops and raise livestock, maintaining a strong connection to the land. The supermarket supplements their efforts, offering essentials like flour, sugar, and a variety of groceries, including frozen bread and products typical of UK or South African supermarkets. And even though the island's economy relies heavily on fishing, especially for rock lobsters, the islanders remain largely self-sufficient, a testament to their resilience and resourcefulness. Now, let's journey to another destination, even harder to reach, a place that takes remoteness to a whole new level. We're heading to the infamous Hypoxia City, a place with the thinnest air on the planet. Of course, that's just a nickname. Its real name is La Rinconada. This city clings to the mountains of Peru. Getting there requires a climb of over 16,000 feet. What would you expect from the highest city on Earth? Despite its challenging location, La Rinconada is home to a surprisingly large population, somewhere between 30,000 and 50,000 people. While the island in the middle of nowhere, St. Helena, looks idyllic, La Rinconada presents a stark contrast. The urban landscape is dominated by low-rise residences, with limited access to essential services. The city lacks a reliable supply of running water and has no sewage system. Adding to the challenges, there's no waste collection service, forcing residents to either burn or bury their garbage. Moreover, until the early 2000s, La Rinconada didn't even have electricity. Most necessities, including the most basic foods, must be brought in from the outside. Despite its humble beginnings as a minor city, La Rinconada now boasts a range of activities that sustain its inhabitants. Some are busy trading food and clothes, while others provide services. Some even operate public restrooms. Architecturally, La Rinconada offers very little. The pattern is predictable: huts made from corrugated metal, unstable and rusting. The choice of materials is dictated by practicality. These metal sheets are the lightest and easiest for miners to transport to the glacier. Unfortunately, these homes lack proper insulation, leaving residents shivering in the cold. Even though they have access to wool from local sheep, an excellent insulator, sturdier rock homes are rare, typically inhabited by wealthier miners. While the architecture may not be captivating, the vistas certainly are. From nearly every spot in La Rinconada, a glance upward reveals La Bella Durmiente, or Sleeping Beauty, a massive glacier towering over the town. Getting to La Rinconada is an arduous journey. First, you'll need to fly into Alejandro Velasco Astete International Airport in Cusco, Peru. Once in Cusco, you can take a train or a bus to Puno, located near Lake Titicaca. Here's where it gets tricky. The only way to reach La Rinconada is by hitchhiking or finding a ride into the mountains. There might be some buses, but they don't operate on a set schedule. If you're feeling adventurous, you can rent a car, but be warned, the roads can be rough and difficult to navigate. Extra caution is essential on this challenging route. Unlike St. Helena, which embraced cash in the 1940s, La Rinconada doesn't rely much on it. The economy of this city is based primarily on gold mines. These mines are unguarded, unregulated, and often dangerous. Miners work for 30 days under a cachorio system. On the 31st day, they are allowed to take as much ore from the mine as they can carry as payment. La Rinconada has no banks, but it has many storefront fund transfers. Imagine a world untouched by modern life, where survival hinges on resilience and adaptation. Our journey begins in remote corners of the earth, places that test the limits of human endurance. First, picture the agency offices, bustling hubs where miners send their hard-earned money to loved ones. Yet, a shadow of uncertainty hangs over them. They can never be sure just how much they'll be able to wire home. Their lives are a constant gamble. Our next stop, Longyearbyen, a town perched near the top of the world. The climate might seem harsh, even unwelcoming, but the locals greet everyone with open arms. No visa is needed to visit or even work here, adding to its unique appeal. Longyearbyen, the capital of Svalbard, boasts a fascinatingly diverse community. Over 50 nationalities are represented among its 2,400 residents. Imagine that, a true melting pot in the Arctic. You might even spot a polar bear wandering into town, a stark reminder of the untamed wilderness that surrounds them. The living space here is compact. There's just one grocery store, and the streets are numbered instead of named, adding to the town's distinctive feel. Longyearbyen also boasts a university center with around 300 students. Interestingly, every student must learn to use firearms for safety in the surrounding wilderness. Originally, Longyearbyen was founded as a mining town, much like La Rinconada. But the focus has shifted mainly to tourism. However, a quirky tradition remains from its mining days. Visitors and residents alike take off their shoes when entering hotels and restaurants. This practice was born out of the need to keep coal dust at bay, a practical solution in an unforgiving environment. Our final destination for today is Palmerston Island, a remote coral atoll in the Cook Islands located about 290 miles northwest of Rarotonga. The famous explorer James Cook visited it on June 16, 1774. Incredibly, the island was uninhabited at the time, despite ancient graves found there. A mystery lost to time. Today, the island supports a small population of just 25 residents, primarily descendants of 19th century English sailor William Marsters. Marsters arrived in 1863 with 2 Polynesian wives and later added a third, fathering 23 children. His legacy lives on in this isolated paradise. Fishing is the mainstay of the local economy, resembling subsistence living. Due to the island's isolation, modern amenities and communication services are available, although there's no airport. Cargo ships visit periodically, bringing essential supplies and a lifeline to the outside world. Now, let's shift our perspective, leaving Earth behind. Imagine you step onto the surface of the moon. It's an unusual sensation. You definitely feel lighter here, and it's easier to walk. You decide to check out that obsessive idea of yours. Jump on Earth's natural satellite. Even despite your bulky spacesuit, you literally fly up into the air. An exhilarating, almost unbelievable experience. Anyway, you can continue your walk on the surface of the moon when you feel something strange. The ground under your feet. Is it shaking? It feels as if an earthquake has just started on the moon, but that's simply impossible. Or is it? Surprisingly, your gut feeling hasn't let you down this time. Moonquakes do exist. In fact, there are 4 types of moonquakes that are strong enough to be detected from a large distance. There are deep moonquakes, occurring more than 430 miles below the surface. Then, there are meteoroid impacts. Thermoquakes occur when the frigid lunar crust expands. This happens when the morning sun illuminates the satellite after a 2-week-long deep freeze lunar night. And there are also shallow moonquakes. They're the only ones that are similar to earthquakes on our planet. Shallow moonquakes happen 12 to 19 miles below the surface, and they're the most powerful and dangerous. Between 1972 and 1977, the Apollo seismic network recorded 28 such moonquakes. Some of them measured more than 5 on the Richter scale. On Earth, such an earthquake is strong enough to crack plaster and move heavy furniture. Plus, shallow moonquakes are very long-lasting compared to earthquakes. Once they get going, they can continue for up to 10 minutes. As for the average earthquake, it typically continues for 10 to 30 seconds. Scientists are still not sure what causes shallow moonquakes and even where exactly they occur. One of the theories is that moonquakes happen at the rims of large, relatively young craters that probably slump from time to time. Interestingly, the Moon and Earth aren't the only places where seismic activity occurs. Mars, our red neighbor, also experiences quakes, though they are less frequent and intense than those on Earth. The study of these seismic events helps us understand the internal structure and geological processes of these celestial bodies. It's a window into the very heart of these worlds. Earthquakes, those sudden and often devastating tremors, are a powerful reminder of the forces at play beneath our feet. While predicting the exact moment an earthquake might occur remains elusive, we have learned much about their causes and patterns. Earthquakes can be triggered by volcanic eruptions or, say, meteor impacts, but most of them are caused by the movements of our planet's tectonic plates. Earth's surface consists of 15 to 20 constantly moving tectonic plates. Pressure increases when they shift, and this can make the crust of our planet break. The consequences can be catastrophic, reshaping landscapes and claiming lives. Consider this. San Francisco is moving toward Los Angeles right at this moment. The speed of its movement is about 2 inches per year. That's as fast as your fingernails grow. It's happening because the 2 sides of the San Andreas Fault, which is the continental fault extending 750 miles through California, are slipping past each other. So, in several million years, Los Angeles and San Francisco will be neighbors. A geological timescale at work, slowly but surely, transforming the map of California. Even seemingly stable bodies of water, like lakes, ponds, and canals, can be affected by these shifts, sometimes subtly, sometimes dramatically. Imagine a world rocked by forces beyond our comprehension. Picture this. The air grows heavy, thick with a strange metallic tang. It's warmer than usual, almost stifling, and carries an undercurrent of decay. A foul odor begins to permeate the atmosphere. This isn't merely unpleasant, it's a primal warning. Millions of years ago, these would have been the harbingers of seismic upheaval. Before a major earthquake, subtle cues ripple through the environment as tectonic plates grind and shift deep beneath the surface. Gases forced from the Earth's crust trigger a cascade of changes. Most animals acutely sensitive to these shifts react in ways we are only beginning to understand. Consider the bizarre case documented in Italy in 2009. Toads en masse vanished completely before a major earthquake struck. Then, as mysteriously as they disappeared, they returned once the disaster subsided. Even after the earth stops shaking, the after effects can linger. Picture a swimming pool, the water still sloshing violently from side to side. Don't be alarmed. This is a phenomenon known as a seiche, a standing wave that can persist for hours after the initial quake. The University of Arizona witnessed this firsthand when their pool lost water due to a seiche triggered by an earthquake in Mexico. A quake that occurred a staggering 200 miles away on February 27, 2010. That same year, a colossal earthquake, registering 8.8 on the Richter scale, tore through Chile. The force was so immense that the Earth's crust was dramatically reshaped. The city of Concepcion was physically displaced, shifting a full 10 feet westward. And the impact isn't always lateral. In 2015, a magnitude 7.5 earthquake rippled through the Himalayas, causing several of the world's tallest mountains, including Mount Everest itself, to shrink by approximately an inch. The Earth breathes, contracts, and expands, a constant reminder of the titanic forces at play. Throughout history, cultures have sought to explain these terrifying events. The Japanese, for instance, believed that earthquakes were caused by namazu, a colossal catfish dwelling in the mud beneath the islands. When this behemoth thrashed, the land trembled. The ancient Greeks attributed earthquakes to Poseidon, the god of the sea, who, in his rage, would strike the earth with his trident. Hindu mythology speaks of 8 elephants holding the world aloft, balanced on the back of a giant turtle, which itself rests upon a massive serpent. When any of these creatures stirred, the earth shuddered. Now, let's transport ourselves to sunny California. Imagine hiking through the San Lucian Mountains. Suddenly, a chilling sensation washes over you. The feeling of being watched. You scan the landscape, but see nothing. Then, your gaze drifts to the distant mountain peaks. Your heart leaps into your throat. There, silhouetted against the sky, is a colossal humanoid figure, its arm outstretched, encircled by a magnificent full rainbow. This mysterious being is clad in black. Its features are indistinct, impossible to discern, yet you can see it moving. Then, in the blink of an eye, it vanishes. You've just encountered the Dark Watchers, a phenomenon that has haunted hikers in these mountains for over 300 years. Even today, science struggles to fully explain these spectral apparitions. One theory suggests that the silhouettes are illusions, tricks of the mind conjured from shadows cast by clouds on the mountainsides. Over generations, the legend has taken root, shaping perceptions and imbuing the shadows with recognizable forms. It's akin to seeing faces in toast or animals in clouds, the human brain's innate desire to find patterns. The most widely accepted explanation is the Brocken specter, an optical phenomenon where sunlight is bent by fog or clouds, creating the rainbow halo. The shadow itself is merely your own, elongated and projected onto the mountainside when the sun is behind you. Natural or not, the vanishing act of these mysterious figures can be unnerving. Let's journey to a different extreme, Antarctica. Endless snow, blinding ice, and relentless sun. A desert of a different kind. The light is almost unbearable. You squint, and in the distance, a splash of red breaks the monotonous white. As you approach, it becomes clear. A waterfall, but not like any you've seen before. An ominous red cascade flows from a glacier, staining the pristine snow with crimson. These are the bloodfalls, and their origin is as fascinating as their appearance. Millions of years ago, a glacier formed over a pond, sealing it off from sunlight, heat, and oxygen. Eventually, the pond found a way to breach the glacier, releasing a trickle of water. This water, saturated with salt and high levels of iron, reacts with the oxygen in the air, creating the scarlet, rust-colored flow. It's a unique spectacle, the only waterfall of its kind on Earth. Our next destination is the Namib Desert. Here, amidst the arid grasslands, you'll find another enigma. Fairy circles. These are near-perfect circles of barren dirt, devoid of vegetation, scattered across the landscape like giant polka dots. Their cause remains a mystery. The leading theory points to termites, which may be consuming the grass around their underground colonies. This could also explain the circle's varying sizes as the insects continue their relentless work. Imagine stepping into a world of bizarre natural phenomena, a world where the ordinary is turned upside down. Let's begin our journey in the realm of termites. Picture a vast, interconnected network of termite colonies. They diligently consume everything in their path as their population explodes outwards. Yet, an unspoken agreement seems to exist. These colonies halt their expansion just before encroaching upon a neighboring colony. It's a peculiar form of prehistoric etiquette. These patches of grassland act as natural boundaries, demarcating territories between rival termite factions. Now, let's journey to the sun-baked landscapes of Australia, to the shores of Lake Hillier. Prepare to have your senses deceived. Before you lies a lake shimmering with the vibrant hue of bubblegum pink. Rest assured, this isn't some toxic concoction. It's perfectly safe to take a dip in. This colossal pink puddle is a salt lake, and it's not alone in its chromatic peculiarity. Salt lakes owe their surreal coloration to a unique blend of algae and microorganisms thriving within their briny depths. These tiny organisms produce a red pigment, acting as a natural sunscreen, shielding them from the harsh solar radiation. What sets Lake Hillier apart is that its waters retain their pink vibrancy even when scooped into a glass. Unlike other pink lakes, its color remains constant throughout the year. Our travels now take us to the lush landscapes of Southeast Asia, where we encounter a tree that appears to be splattered with paint. This is the rainbow eucalyptus, a masterpiece crafted by nature herself. Its bark undergoes a mesmerizing transformation, changing colors over time like a living kaleidoscope. The process begins with a fresh, bright green shade. As the tree matures, the bark morphs into vibrant hues of red, orange, and purple before finally settling into a mature brown. Then, the colorful cycle begins anew. Next, we witness a spectacle that seems ripped from the pages of a horror novel. Blood rain. While the name evokes images of something sinister, the reality is far less alarming. This weather phenomenon has been observed since the days of ancient Rome. Powerful winds sometimes whip up red dust high into the atmosphere, carrying it vast distances. Eventually, this dust mingles with rain clouds, tinting the precipitation a startling crimson. Dust from coal mines can create black rain, while pollen is often the culprit behind yellow rain. Certain other types of dust can even turn rainwater white. In 2009, the residents of Ishikawa, Japan, experienced a rainfall unlike any other, a shower of tadpoles. One theory suggests that unusually strong winds lifted the tiny amphibians into the air, carrying them aloft before releasing them in a bizarre cascade. Another explanation proposes that large birds, such as gulls, were transporting the tadpoles to their nests when they accidentally dropped their cargo. Some scientists even believe that waterspouts may have been responsible, scooping up the creatures and depositing them far from their original habitat. That day, people found not only tadpoles, but also frogs and fish scattered across the landscape. And the strangeness doesn't end there. Reports exist of worm rain, and some even claim to have witnessed snake rain. In place of ordinary raindrops, some have seen translucent, jelly-like blobs descending from the sky. Now, let's turn our attention to the arachnid world of Australia. Here, spiders have evolved an unusual and somewhat terrifying adaptation: spider rain. This phenomenon is a common occurrence thanks to a behavior known as ballooning. Spiders climb to the highest available point, spin strands of silk, and use them as makeshift parachutes to catch the wind. While usually unnoticed, these mass spider migrations become apparent after rain, when hundreds of spiders seek higher ground. People report seeing spiders drifting down on their silken threads, like tiny balloonists descending from the sky. Our journey continues to the Mekong River, where, if you're lucky, you might witness a captivating display of glowing orbs rising from the water and soaring into the air. Locals call these the Naga fireballs. These reddish spheres vary in size, from as small as a cherry to as large as a watermelon. On a single night, dozens, and sometimes even thousands, of these fireballs can be seen. Scientists lack a definitive explanation for this phenomenon, but the most plausible theory involves flammable gases released by the marshy environment. Local legend, however, attributes the fireballs to a giant serpent dwelling in the river's depths. Our adventure continues as we explore the skies, where shelf clouds look like something straight out of a science fiction movie. They form when warm, moist air becomes trapped in a thunderstorm's updraft. These ominous formations often herald the arrival of severe weather. Equally breathtaking are the iridescent rainbow clouds that sometimes appear atop puffy clouds after a thunderstorm. These low-altitude clouds contain water vapor that condenses into droplets, acting like tiny prisms, splitting sunlight into a spectrum of colors and creating a multicolored cap over the clouds. Morning glory clouds are an exceptionally rare sight. These massive tube-shaped formations stretch across the sky. Most researchers believe they form when an updraft is squeezed through a cloud, creating the cloud's signature rolling appearance. The cool air at the back of the cloud causes it to sink downward. The Gulf of Carpentaria in Australia is one of the best places to witness these magnificent formations, particularly between late September and early November. Finally, we gaze upwards to see huge, white lumps hanging overhead, known as mammatus clouds. They create the illusion that the sky is falling. Most clouds form when air rises in the atmosphere, but mammatus clouds are an exception. They appear when moist, cool air descends and mixes with dry air. Imagine, high above us, unique puffed rice clouds hanging in the atmosphere. A beautiful sight, yes, but a warning too. If you spot this phenomenon, know that bad weather is just around the corner. Nature's own barometer, whispering of impending storms. Now, let's plunge into the depths of the Caribbean, just off the coast of Cuba. Here, in the inky blackness, lies something extraordinary: the Cuban underwater city. Circular columns rise from the seabed, paved floors stretch into the distance, and symmetrical stone structures dot the landscape. What secrets does this submerged metropolis hold? Why was such a grand city abandoned, swallowed by the ocean? Many believe these ruins are remnants of a long-lost civilization, a society whose name and history have been erased by time. But scientists remain skeptical. They propose a more natural explanation: that this lost city is nothing more than a geological anomaly, a formation that appeared roughly 5 million years ago. These disc and donut-like structures, they argue, often form where natural gases vent from the seafloor. The pressure and chemical reactions sculpt the surrounding rock into these peculiar shapes. A fascinating, if less romantic, explanation. Think of the annoying whistle of a boiling kettle. Now amplify that sound, deepen it, and imagine it echoing through the vastness of the ocean. This is the bloop, one of the most mysterious and unsettling sounds ever recorded underwater. While not as blood-curdling as some other unexplained sonic phenomena, the bloop remains stubbornly elusive. In 1997, only a single underwater microphone picked it up. At the time, researchers couldn't pinpoint its source. The leading theory suggests the eruption of a submarine volcano, a colossal release of energy deep beneath the waves. But, as with so many mysteries of the deep, definitive proof remains out of reach. Tunnels, metro systems, secret passageways leading to the mansions of the rich and famous. Why do we build them? To hide, to escape, to connect. Many cities are riddled with underground tunnels, some even possessing entire subterranean doppelgangers. Let's be clear, these passages are usually not connected. Forget the popular rumor of a continuous underground network stretching from Scotland to Turkey, supposedly built 5,000 years ago. Imagine the sheer audacity of such an undertaking, even today. These tunnels have a name: Erdstall tunnels. They likely originated in the Middle Ages, though the exact date remains shrouded in mystery. The highest concentration of these tunnels is found in Bavaria, Germany, but they also appear in Great Britain and France. Erdstall tunnels are a unique type of subterranean passage, characterized by their narrow oval-shaped corridors and constricting choke points known as schlupfe or slip-outs. Despite much speculation, Their true purpose remains unknown. Some tunnels feature fireplaces and ventilation shafts, suggesting they were used for shelter, possibly as early as the 12th century. Because Earth-dull tunnels lack archaeological markers and historical records, many rumors surround their use. Some scientists propose they were storage spaces, though their narrowness makes this impractical. Another theory suggests they served as hiding places for farmers during tribal raids. However, their single entry point raises doubts about their effectiveness in evading threats. Feeling like Indiana Jones? Want to explore these ancient tunnels yourself? A few structures, like the Erdstall Ratgoblucken in Austria, welcome visitors to delve into these enigmatic structures. However, most remain closed to the public. The origins of Erdstall tunnels remain largely unknown, just like their real functions. Think we can study everything in the 21st century? Think again. The tight confines of these tunnels make them difficult to study. Traditional surveying methods often prove inadequate in such cramped spaces. To overcome this, scientists use handheld devices that integrate an RGB camera, a gyroscope, and high-resolution depth sensors, allowing them to capture intricate details. They also employ modern techniques like 3D surveying, hoping to uncover the true origins and purposes of these tunnels. One hypothesis even suggests they may have been poorly conceived dwellings, abandoned when their inadequacies became apparent. But not everyone agrees. Other theories suggest these tunnels served spiritual purposes, while the most intriguing idea speculates that they may be remnants of extraterrestrial civilizations. More grounded experts believe they may have been used for practical matters, such as granaries or hiding spots from looters. Without exact information on who built them and when, the possibilities are endless. It could have been almost anyone. Even a sloth. Yes, you heard that right. Sloths can build giant tunnels. In 2019, a farmer in southern Brazil was driving his tractor through a cornfield when it suddenly sank into the ground. He had broken through the top of an underground tunnel. When researchers investigated, they discovered a tunnel around 6.5 feet high. Imagine a scene unfolding on a seemingly ordinary farm. One day the farmer notices something peculiar. A massive hole, a dark abyss, stretching an incredible 6.5 feet wide and plunging nearly 50 feet beneath his very house. As he cautiously peers into the depths, a chilling discovery awaits. Deep, unmistakable claw marks scar the walls of the tunnel. This is no ordinary cave. This isn't the work of human hands. The farmer has stumbled upon a megafauna paleoburrow, a prehistoric tunnel, a relic of colossal creatures that roamed the earth over 10,000 years ago. Let's journey back in time and conjure up the image of these ancient architects. Take a humble hamster, now amplify its size, transforming it into an elephantine behemoth. And picture this 13-foot-tall hamster, capable of lumbering on 2 legs. These were the giant ground sloths and armadillos that dominated the Americas from about 15 million to 10,000 years ago. They were the engineers of these subterranean marvels. Today, many of these tunnels are filled with the dust and debris of ages, yet some remain eerily clear, much like the one unearthed by the farmer. This 2009 discovery ignited a wave of paleontological interest, leading to the unearthing of over 500 such paleo-burrows across southern Brazil. This region now boasts the highest concentration of these sites anywhere on Earth. Why are they so abundant in this specific locale? The question hangs in the air, a mystery yet to be fully unraveled. While paleo-burrows dot the landscape of South America, their absence in North America is puzzling. After all, giant sloths once roamed freely across the entire continent. The true purpose of these vast tunnels remains shrouded in enigma. Were they nurseries, safe havens for vulnerable young? Did they serve as climate-controlled shelters, offering refuge from the elements? Or perhaps they were hibernation chambers, where these giants slumbered through long winters. These tunnels likely evolved over countless generations, each successive wave of sloths and armadillos expanding and refining the work of their predecessors. Now, let's shift our gaze to a different corner of the world, to the United Kingdom. Forget the Japanese delicacy, fugu, with its deadly potential. And no, We aren't talking about a town in New Guinea. We're on the trail of Phogus. These are underground structures, unlike the tunnels we just explored. These are dry stone structures, as if someone decorated a cave with rocks from the inside. These are only around 15 of them discovered so far, and most are located in Cornwall. Estimates suggest they were constructed roughly 2,400 years ago, and remarkably, they remain in pristine condition. Imagine, these structures were built without the aid of modern machinery. Yet they've endured the ravages of time. Consider the fleeting lifespan of modern construction. How often do we find ourselves dissatisfied with the quality of new buildings? As for the purpose of these Phogus, theories abound. Were they used for spiritual rituals? Did they serve as hiding places in times of conflict? Or were they simply used for food storage? One compelling theory suggests a clever adaptation to the famously humid climate of England. Ancient people were far from clueless. Their survival depended on ingenuity. They may have utilized the Phogus to store foods already containing natural molds, like milk, butter, and cheese, aiding in their preservation. But these are just speculations. The true purpose remains elusive. What distinguishes Phogus is their intentional construction. They weren't simply excavated mines like those found in Wales. Instead, they were meticulously crafted by digging deep trenches, lining them with carefully chosen stone slabs, covering them with capstones, and then burying the entire structure. This undertaking demanded considerable time and effort. Despite the labor involved, cities around the world are often built atop intricate tunnel systems, each reflecting the unique history and needs of its location. Paris, for example, is riddled with abandoned underground quarries, posing a constant threat of collapse in certain areas. London boasts one of the most extensive tunnel networks in the world, including many built for military purposes. New York City is rife with rumors of secret tunnels, while Los Angeles harbors remnants of Prohibition-era tunnels used for speakeasies. Even Florida has its share of subterranean secrets. In 2011, flooding in Ybor City, near a former post office, exposed a section of an unknown structure. Initially, it garnered little attention. But 7 years later, during renovation work, something truly fascinating came to light. This historic neighborhood, founded in the 1880s, possessed a hidden tunnel network. The exact purpose of the tunnels remains a mystery, but most experts believe they were used for. Imagine a hidden world beneath our feet, a labyrinth of tunnels snaking beneath the city of Tampa. These aren't mere drainage systems. We're talking about a clandestine network, whispers of which connect to the city's early gaming dens and the bustling port of Tampa itself. But just how extensive is this subterranean maze? That's the million-dollar question. In 2018, a historic home in the Seminole Heights neighborhood coughed up a secret. Locked doors leading to tunnels, relics from the roaring 1920s. One local even claimed to have journeyed through a tunnel for a full 20 minutes. Rumors persist that some of these tunnels plunge deep enough to connect with the Hillsborough River, weaving their way beneath the city. City research is ongoing, but for now, the secrets remain largely buried. Now, let's shift gears and plunge into the ocean's depths, off the rugged coast of Big Sur, California. Here, on the seabed, lies a mystery that confounds even seasoned marine biologists. Perfect, circular holes etched into the ocean floor. How did they get there? These aren't recent phenomena. Records show these enigmatic holes have been around since the 1990s. A sonar survey in 1999 revealed a staggering 5,200 of these pockmarks, or large holes, scattered across more than 500 square miles of the ocean floor. They resemble lunar craters, eerily beautiful and utterly baffling, underwater. The call goes out. A team is assembled, and a remotely operated vehicle, ROV, or robot, is prepped for a deep-sea dive to explore the scene and retrieve samples. The team speeds to the coast, the boat slicing through the waves. Inside, you grip the joystick, ready to pilot the ROV into the abyss. Your teammate lowers the robot into the water, and it begins its descent. Near the surface, everything appears normal. But as the ROV plunges deeper, the pockmarks begin to materialize, like ghostly footprints on the ocean floor. Suddenly, a flotilla of boats streaks past, rocking your vessel and momentarily disrupting your focus. The ROV's powerful flashlight pierces the gloom, but the deeper it goes, the fuzzier the image becomes. Finally, it reaches the bottom. The holes are smooth, their circular shapes almost too perfect. Some of these craters, visible in the sonar scans, measure over 30 feet across and 15 feet deep. The images flood the monitor, and the team stares in stunned silence. The robot continues its swim, revealing more and more holes. Many are too small to have been detected by the surface scanners. These microdepressions are steep-sided, with subtle tails trailing in a specific direction, hinting that underwater currents might play a role in their formation. Everywhere the ROV goes, new holes appear, an endless field of underwater mystery. After a couple of hours, the ROV returns to the boat, laden with samples. Back at the lab, the analysis begins. The ROV's cameras capture disheartening images of human trash littering the ocean floor, but initial sample analysis reveals nothing alarming. Despite the fact that roughly a third of these pockmarks contain discarded refuse, the question of their origin remains unanswered. Late into the night, the team disperses, heading home to rest. But you, driven by an insatiable curiosity, remain, poring over data, desperately seeking a breakthrough. As dawn approaches, a new idea sparks to life. Could these holes be vents for gas? If so, they could pose a serious threat to marine life. Without hesitation, you grab the ROV and race back to the ocean. This time, there's no time to assemble the team. You launch the robot into the water and take your position behind the controls. The ROV descends once more, surveying the seabed. The holes remain, many still marred by the presence of trash, but some provide shelter for marine life, fish darting in and out, seaweed swaying gently in the current. After extensive scanning, there's no sign of bubbles, no indication of gas venting, but you refuse to give up. Eventually, you reach one of the larger pockmarks, and the ROV's sensors detect something. Faint bubbles emanating from a source deep within the hole, a source the robot can't reach. It swims around, searching for an opening, but to no avail. Back at the lab, you modify the ROV, equipping it with a pair of mechanical arms capable of lifting and moving objects. With the upgraded ROV, you return to the same pockmark. The bubbles are less frequent now, but they're still there. Carefully, you use the mechanical arms to clear away some of the trash, and the source is revealed. A cluster of crabs, happily nestled next to a pile of plastic, their movements creating the illusion of venting gas. Bingo? Not quite. The mystery of the micro-depressions and pockmarks remains unsolved. As you prepare to bring the ROV back to the surface, disaster strikes. An octopus, its eyes gleaming with curiosity, or perhaps hunger, wraps its powerful tentacles around the ROV, pulling it down. You fight with the controls, pushing the robot to its maximum power, but the octopus's suction is too strong to break. It's a tug of war between man and cephalopod, a battle for the fate of the ROV. The octopus drags the robot beneath a pile of trash, mistaking it for a potential meal. But with skillful maneuvering of the mechanical arms, you manage to free the ROV and send it hurtling back towards the surface. You return to the lab, even more perplexed than before. The ROV has collected more samples, and you spend hours hunched over a microscope, searching for answers. But the ocean's secrets remain elusive. Frustrated, you decide to perform a carbon dating test. Perhaps the age of the sediment will provide a clue. Let's imagine you're a scientist, driven by an insatiable curiosity. Months have passed since the discovery of those strange holes on the ocean floor. Now, it's time to determine their age. After painstaking analysis, the results come back, and they are more shocking than you could have imagined. The tests reveal that these pockmarks are approximately 400,000 years old. This effectively rules out recent human activity as the primary cause. Countless sleepless nights follow, fueled by coffee and the burning desire to uncover the truth. You reconvene your team, holding a small press conference. You cautiously suggest that this discovery might indicate something profoundly concerning, but you are still limited by the unknown. After weeks of relentless investigation, a breakthrough. The older, larger pockmarks have remained unchanged for at least 50,000 years. The more recent holes, it seems, are likely the result of human trash accumulating on the seabed. Marine life, in a tragic twist, has incorporated this debris, plastics, discarded fishing gear, into their habitats. This explains the roughly 4,500 newer holes containing modern refuse. But the origin of the original ancient holes remains a chilling enigma. You are back to square one. The only path forward is to meticulously clear the underwater trash and directly examine the seabed. The story explodes in the local news, eventually reaching a dedicated cleanup crew. A joint expedition is rapidly organized. You find yourself on the open ocean, coordinating the massive cleanup effort. Boats converge on the site, deploying nets to collect the accumulated debris. The underwater robot, your trusty companion, is sent down to ensure accurate targeting. As the nets sweep across the seabed, marine life scatters, desperately seeking refuge. The entire team is vigilant, ensuring minimal harm to the displaced creatures. Weeks later, the area is finally clear. Another sonar scan reveals the holes with unprecedented clarity. Yet the mystery persists. Your research intensifies, expanding to encompass similar anomalies around the globe. Across the continent, a report surfaces about a mysterious blue hole off the coast of Florida. You book the first available flight, arranging a meeting with the lead scientist of the Blue Hole expedition. Blue holes, it turns out, are underwater sinkholes, cavernous openings below the seabed. Similar to sinkholes on land, they represent a unique geological feature. This particular one, nicknamed Green Banana, lies 15 feet below the surface and plunges to a staggering depth of 435 feet. Donning specialized diving gear, you and your team descend into the inky depths. The ocean floor appears barren, lifeless. Then, the blue hole emerges. A vibrant oasis in an aquatic desert. An astonishing array of marine life thrives within its depths. Sea turtles glide past, and even sharks circle cautiously. Thankfully, these sharks pose no threat to humans. Halfway down, the passage narrows, making navigation difficult. With extreme caution, the team presses on, marveling at the corals, sponges, and mollusks clinging to the walls. Samples are collected for later analysis back at the lab. It quickly becomes clear that blue holes are exceptionally rich in nutrients, supporting a unique ecosystem unlike the surrounding barren landscape. These formations are relatively common and generally pose no danger. After careful consideration, you conclude that the California holes are fundamentally different from Florida's blue holes. The mystery endures, a haunting question mark on the ocean floor. But the Earth itself holds more secrets and more potential threats. Consider the strongest earthquake ever recorded east of the Mississippi River. It occurred over 2 centuries ago, and according to some scientists, it may still be reverberating. Most earthquakes last mere seconds or minutes. The current record holder is a silent earthquake in Sumatra, a slow slip event that persisted for an astounding 32 years. This event eventually triggered a massive quake and a devastating tsunami. If the New Madrid earthquake is still producing aftershocks, it could claim the title of the longest-lasting seismic event in history. The New Madrid earthquake began in December 1811 with a powerful tremor in a sparsely populated region of northeast Arkansas. The shaking was felt nearly 1,000 miles away, even in the White House. Church bells rang in Boston, a testament to the quake's immense power. The Mississippi River, incredibly, flowed backward for a short time, and new waterfalls formed as the ground shifted violently. The town of New Madrid, Missouri, was utterly destroyed. The earth refused to remain still. In January of the following year, another massive quake struck near the confluence of the Ohio and Mississippi rivers in the Missouri Bootheel. Geologists believe this was a rupture along the New Madrid Fault, placing immense strain on the nearby Reelfoot Fault. Just when it seemed things couldn't worsen, 2 weeks of relentless tremors culminated in a catastrophic event. The Reelfoot Fault ruptured deep beneath New Madrid, down into Tennessee. Approximately 15 miles south of New Madrid, the ground uplifted dramatically, creating Reelfoot Lake. steamboats once plying the river. Imagine the scene. Thousands upon thousands of trees ripped from the earth, floating aimlessly on a turbulent sea. Acres of primeval woodland, pulverized and scattered by a cataclysmic quake. Let's journey back to 1811, when the earth groaned and shuddered with unimaginable force. The tremors didn't stop there. In St. Louis, Missouri, a city a full 160 miles distant from the epicenter, buildings sustained serious damage. Chimneys collapsed into the streets of Cincinnati, Ohio, a staggering 400 miles away. Astonishingly, even in Montreal, Canada, over 1,000 miles distant, people felt the unmistakable shiver of the earth in motion. Since 1974, seismologists have meticulously recorded approximately 200 minor earthquakes each year, emanating from the New Madrid seismic zone. Some scientists propose that as much as 30% of these ongoing tremors could be lingering aftershocks, ghostly echoes of those colossal quakes of 1811 and 1812. In regions of the United States characterized by relative tectonic stability, these aftershocks might persist for decades, perhaps even centuries, after the initial devastating event. Aftershocks represent the Earth's method of gradually dissipating the immense stress accumulated from the primary quake. When the ground convulses during the main earthquake, it exerts tremendous pressure on the surrounding rock formations. When these rocks reach their breaking point, they fracture, triggering further seismic activity, the aftershock. These can be particularly intense in the immediate aftermath of the main quake, gradually diminishing in strength over time. However, not all scientists concur that contemporary earthquakes are necessarily linked to those events of 2 centuries past. We tend to primarily associate fault lines with the boundaries where the Earth's tectonic plates converge. Yet, a complex network of fault lines exists directly beneath the heart of the North American plate. These are essentially remnants from approximately 750 million years ago, a time when North America constituted part of a vast supercontinent known as Rodinia. As Rodinia began to fragment, it left behind these rifts, structural weaknesses embedded deep within the Earth's crust, underlying the modern Midwest. This could potentially account for the ongoing seismic activity. An international team of geologists embarked on a mission to re-examine 3 significant earthquakes that shook North America, aiming to resolve this ongoing debate. They employed a novel mathematical approach termed the nearest neighbor method. This method posits that if earthquakes occur too closely in space, time, and magnitude to be considered independent background events, it's reasonable to assume one triggered the other. Depending on the specific parameters used in the analysis, estimates suggest that between 10% and 65% of recent quakes in the region could be aftershocks stemming from those historic earthquakes. Furthermore, a massive earthquake that struck Charleston, South Carolina, in the late 19th century might account for as much as 72% of the earthquakes in that area since. But geological realities vary from place to place, so the scientific debate persists. Now, let's shift our focus to the other side of the world. Back in 1774, the intrepid British explorer James Cook observed a distant glow on the horizon. This was the fiery visage of Mount Yasur, a volcano located in Vanuatu. This restless giant has been relentlessly spewing lava and ash for countless years, potentially stretching back far beyond recorded history. The volcano has been maintained at an elevated alert level since October 2016, indicating a state of heightened instability. A 2,000-foot radius exclusion zone has been established around the crater to ensure public safety. Low to moderate eruptions frequently occur, ejecting ash, gas, and steam into the atmosphere. Occasionally, more powerful blasts hurl debris beyond the crater's rim. Satellite imagery has detected persistent hotspots and plumes of sulfur dioxide, confirming that Mount Yasur remains intensely active beneath the surface. Meanwhile, on Stromboli, one of the volcanic islands situated near Sicily, stands a volcano that holds the Guinness World Record for the longest continuous eruption. This fiery spectacle has been ongoing for over 2,400 years. Ancient mariners affectionately dubbed it the lighthouse of the Mediterranean. Most of the time, Stromboli simply spits out molten rock, but periodically it unleashes lava flows or impressive fountains of fire. On occasion, observers might even witness steam-driven explosions. Now, let's travel back over 200 million years to a time when the world underwent a profound transformation. Not one, not two, but four massive volcanic eruptions reshaped the planet. This all unfolded in Rangelia, a vast island arc that once encompassed a supervolcano stretching across what is now British Columbia and Alaska. This colossal volcanic activity may have played a crucial role in the evolutionary trajectory of dinosaurs, potentially contributing to their growth from relatively small, cat-sized creatures into the colossal giants we remember from Jurassic Park. The eruptions triggered a prolonged rainy season, lasting a staggering 2 million years. The entire planet became swelteringly hot and humid, conditions that seemingly favored the proliferation of dinosaurs. Researchers meticulously analyzed sediment layers extracted from beneath an ancient lakebed in China, uncovering compelling evidence of these cataclysmic events. They discovered traces of volcanic ash and mercury, unequivocal indicators of those epic eruptions. Furthermore, carbon signatures revealed dramatic spikes in carbon dioxide levels, resulting in a warmer atmosphere and torrential rainfall. These events transpired in four distinct pulses, each instigated by those monstrous volcanic blasts. Finally, let's consider a remarkable site located within a national park not far from Sydney, Australia. Here, a subterranean fire has been burning continuously for at least 6,000 years. This place is known as Burning Mountain, and it represents a coal seam fire relentlessly consuming its way through the earth. Imagine a tranquil coastal garden bursting with life. Now picture it all vanishing in an instant. Salt water surges inland, a death sentence for every tree and plant. A temporary environmental shift becomes a scene of utter devastation. But there's a morbid silver lining. Instant Halloween decor. The skeletal remains of drowned trees form a ghostly forest, a grim monument to nature's power. But this isn't just a flood. This is a cataclysm. The confluence of colossal waves, earth-shattering quakes, and the sheer geographical scale dwarfs any disaster caused by the San Andreas Fault, or even the big one we fear so much. History offers chilling echoes. Roughly 300 years ago, a similar quake ravaged this region, and the geological record spanning 3,500 years reveals a recurring pattern. These megaquakes strike every 400 to 600 years. By that timeline, we might have a reprieve of 100 to 300 years before the next one hits. The Cascadia Subduction Zone, a relatively recent discovery in 1970, remains shrouded in mystery. This zone is a sleeping giant, capable of unleashing earthquakes of unimaginable magnitude. Its discovery was almost accidental, a byproduct of research into the Ring of Fire. Scientists sought to understand if this area had a history of seismic activity. The answer lay hidden in plain sight, in a horror forest in Washington state, where life refuses to take root. Soil samples revealed an abnormally high salt content. The pieces fell into place. A massive tsunami, centuries ago, had poisoned the land. Historical records from Japan confirmed their suspicions. The Japanese documented a colossal earthquake in the year 1700, an event that mirrored the devastation in Washington. Now, experts estimate a 1 in 3 chance that the next megaquake could strike by 2050. For those living in the affected regions, understanding survival strategies is paramount. The initial earthquake, while terrifying, is only the opening act. The real danger lies in the tsunami that follows. After the shaking subsides, the immediate priority is to reach high ground. Forget your prized possessions. Leave your baseball card collection behind. Focus on essentials: food, water, and the will to survive. And don't be fooled by a lull in the action. Seismologists warn that multiple waves are likely. The events of May 22, 1960, provide a stark lesson. Seismologist Jerry Eaton and his team traveled to Hawaii to observe an anticipated tsunami. They positioned themselves on the Wuku Bridge, equipped with an escape route. This bridge, already rebuilt after a previous tsunami, seemed a safe vantage point. They were wrong. After midnight, the water level rose dramatically, exceeding the average by 4 feet. A second wave, just 30 minutes later, added another 9 feet to the surge. By 1 a.m., The water began to recede, dropping 7 feet. But the reprieve was an illusion. A monstrous wave, estimated at 20 feet high, loomed on the horizon. This terrifying episode underscores the unpredictable nature of tsunamis and the critical importance of heeding expert advice. Deep beneath the ocean floor, a titanic struggle unfolds. Tectonic plates collide, one relentlessly forced beneath the other in the Pacific and Indian Oceans. Centuries of strain build, the tension reaching an unbearable crescendo. Finally, the megathrust awakens. The Earth convulses, registering a magnitude that can eclipse 9 points, a force unmatched by any other earthquake. The sudden uplift of the seafloor unleashes a colossal ripple, a tsunami of unimaginable power. These tailhead tsunamis traverse entire ocean basins, poised to engulf coastlines thousands of miles away. The rupture zone can extend for over 600 miles. The Earth doesn't just shake, it feels as though it's being ripped apart. This is the raw, untamed power of a megathrust earthquake. Those caught in its path face a desperate fight for survival. Recently, Japanese authorities issued their first ever megaquake advisory, triggered by a strong tremor along the Nankai Trough ocean floor zone. While the warnings were eventually lifted and the damage from the 7.1 magnitude earthquake was minimal, the event served as a stark reminder of the ever-present threat. High-speed trains were temporarily slowed as a precaution, disrupting travel but prioritizing safety. The Japanese people remained vigilant, acutely aware of the potential for a catastrophic megathrust earthquake within the coming decades. In the Nankai Trough, the tectonic plate beneath the Philippine Sea is slowly, inexorably, sliding beneath the Japanese landmass, a movement of mere inches per year. The last major earthquakes in this region occurred in 1944 and 1946, both registering a magnitude of 8.1. These quakes inflicted widespread destruction. Scientists disagree on the likelihood of another megathrust earthquake, but some estimates suggest an alarming 80% probability. Across the Pacific, the U.S. Geological Survey is closely monitoring another volatile region along the U.S. coastline. Imagine a place where the Earth itself is ablaze, not with roaring flames, but with a slow, insidious burn. We find ourselves standing before a mountain, concealing a hidden inferno. Beneath our feet, a layer of coal lies smoldering, a subterranean fire that began long ago. Once ignited, these underground blazes are virtually impossible to extinguish. This fiery mass stretches up to 30 feet wide, radiating intense heat, yet devoid of visible flames. It's a smoldering beast creeping forward at a glacial pace of approximately 3 feet per year. A local farmer, centuries past, in the 19th century, first stumbled upon this phenomenon, mistaking it for a slumbering volcano. Local legends whisper of the fire's origins, attributing it to the sorrowful tears of a widow or the fallen torch of a hero. But scientific minds suggest more earthly causes, a lightning strike perhaps, or the slow, steady heating of coal, much like a barbecue igniting on a summer's day, fueled by its interaction with the very air we breathe. Some even speculate that this fire has been burning since before the dinosaurs walked the earth, a timeless inferno. The exact duration of its fiery existence remains shrouded in mystery, as does its future path. Currently, the coal possesses enough oxygen to sustain its burn for centuries, perhaps even millennia, untouched by human intervention. The fire is transforming the mountain into a colossal oven, causing the earth to crack and crumble, creating fissures that invite more life-giving oxygen to feed the flames. Even with human intervention, these coal seam fires demand immense resources, truckloads of water and liquid nitrogen, to bring them under control. Several years ago, explorers made a concerning discovery. The smoldering edge was inching perilously close to a cliff overlooking a small river. The future holds uncertainty. Depending on the coal seam's next move, we could witness dramatic shifts in the landscape in the decades to come. Perhaps a burst of intense flames, or the fire could plunge deep, extinguish itself, and fade away. Now, let's journey to another geological hotspot, Yellowstone National Park. This natural wonder sits atop a colossal supervolcano, the source of its iconic geysers and hot springs. Beneath the surface lies an enormous magma chamber, a reservoir of molten rock. In 2015, researchers at the University of Utah made a startling discovery. This chamber was far larger than previously imagined. They even uncovered an additional magma reservoir beneath the first. The more spacious the chambers, the greater their capacity for magma. Combined, these two reservoirs hold enough molten rock to fill the Grand Canyon not once, but 11 times over. But here's the unsettling truth. These magma chambers exert pressure on the ground above, causing the land in Yellowstone to rise approximately 1 to 2 inches each year. Yellowstone is classified as an active volcano, possessing a volcanic explosivity index of 8 out of 8. This ominous number signifies that a full-scale eruption would be an apocalyptic event. To put this into perspective, the 1991 eruption of Mount Pinatubo in the Philippines, considered the most powerful in recent memory, registered a 6 on the same index. But is there cause for immediate alarm? In March 2023, the University of Utah seismograph stations recorded 354 earthquakes within the Yellowstone National Park region. While this may seem significant, the most notable event was a minor earthquake with a magnitude of 3.7. It was part of a swarm of 106 earthquakes that began on March 29th and persisted until the month's end. Even earthquakes, it seems, can occur in swarms. Experts assure us that Yellowstone's seismic activity is somewhat elevated, but not critically so. Michael Poland, a geophysicist at the Yellowstone Volcano Observatory, asserts that an eruption is not imminent. For an eruption to occur, there must be a sufficient quantity of magma ready to erupt beneath the surface, along with enough pressure to force it upwards. According to Poland, neither of these conditions is currently met. Yellowstone, for now, remains stable. Nevertheless, Poland and his team maintain vigilant surveillance, monitoring various forms of underground activity for early warning signs of potential eruptions. These include the frequency of earthquakes and ground deformation. Thousands of minor earthquakes, coupled with significant changes in the ground surface, could raise alarms. The team also monitors the temperature of the park's thermal features, another crucial indicator of potential unrest. Park-wide changes in geyser activity, as well as gas and thermal emissions, are carefully scrutinized. Despite media speculation suggesting an impending eruption due to the 70,000-year interval since the last major event, experts dismiss this notion. Volcanoes, they explain, do not adhere to strict timelines. Should a super-eruption occur, the most immediate threat would not be lava flows or earthquakes. Imagine the scene. Millions of years ago, a natural disaster of unimaginable scale is brewing. But it's not just any disaster, it's a super-eruption, a cataclysmic event that would reshape the very landscape and plunge the world into a prolonged winter. The worst part, the ash, the relentless suffocating ash fall. Let's journey back to when the Yellowstone volcano, a sleeping giant beneath the North American continent, unleashed its fury. Over its long history, Yellowstone has experienced at least 3 super-eruptions. The most powerful, a staggering 2,500 times more destructive than the infamous Mount St. Helens eruption in 1980. Then there was the Lava Creek eruption, a more recent event that carved out the Yellowstone caldera we know today, spewing forth a terrifying cocktail of dust, volcanic ash, and molten rock. Recently, paleontologists have uncovered evidence of 2 previously unknown super-eruptions occurring roughly 9 and 8.7 million years ago. The younger of these 2 is now considered the largest recorded event within the Snake River Yellowstone volcanic province. But what exactly was happening in the lead-up to these monstrous events? Picture this. For millennia, intense heat had been building deep within the Earth. This subterranean furnace was melting rock, creating vast chambers filled with a pressurized concoction of semi-solid magma, superheated water vapor, and a variety of gases, including deadly carbon dioxide. As more and more magma surged into these underground reservoirs, the land above began to rise, almost imperceptibly at first. A year before the super-eruption, Yellowstone offered a warning sign, a mere burp compared to what was to come. But in a world without seismographs or volcanologists, these subtle signals went unheeded. Deep underground, Decompression was releasing gas bubbles within the magma. The bursting of these bubbles would ultimately fuel the explosive eruption. Months before the main event, small-scale earthquakes grew increasingly frequent and intense. The ground in many areas of the supervolcano became noticeably hotter, and surface lakes and groundwater experienced a similar rise in temperature. Had humans been present, they would have observed unusual steam rising from the ground, a ghostly fog hanging in the air. In the days immediately preceding the eruption, the growing pressure forced the ground above the magma chamber to bulge upward, forming a massive dome. Narrow cracks began to spiderweb across the surface of this uplift. Imagine shaking a bottle of soda and then slowly twisting the cap. The pressure was building, seeking release. As gases burst forth from beneath the surface, the ground around Yellowstone rose dramatically. Geothermal pools and geysers heated to boiling point, becoming increasingly acidic. The magma was relentlessly pushing its way toward the surface. Finally, the rock roof of the magma chamber could no longer withstand the immense pressure. The eruption began. Small, constant tremors rippled through the ground in the days prior, but the true shaking didn't commence until minutes before the main explosion. With a deafening roar that would have shattered eardrums, a colossal column of lava and ash shot skyward. Within moments, a pyroclastic flow, a terrifying river of molten rock, volcanic ash, and superheated gases, surged across the landscape at hurricane speeds. This wasn't snow. It was a toxic avalanche with temperatures reaching a blistering 300 degrees Fahrenheit, incinerating everything in its path. For days on end, the volcano relentlessly pumped ash into the atmosphere. For all living creatures, this ashfall would prove to be one of the deadliest consequences of the eruption. Volcanic ash, upon inhalation, hardens into a glassy cement within seconds. Most animals had no chance. Even the largest, thickest trees buckled and collapsed under the weight of this dense, suffocating substance. Within days, a thick blanket of ash had enveloped vast territories. As the ash reached the stratosphere, global temperatures began to plummet. The eruption released massive quantities of sulfur, an effective sunblocker. The result? A prolonged volcanic winter. For years, the world experienced a year without a summer. Animals struggled to find food and clean water in the perpetual gloom. This natural disaster, which paleontologists have dubbed the Gray's Landing super eruption, was truly colossal. The lava flows alone entombed an area the size of New Jersey in scorching hot volcanic glass, instantly sterilizing the land and obliterating all plant life. Imagine for a moment a cataclysmic eruption. If such an event were to unfold today, the consequences would be staggering. A blanket of toxic volcanic ash, potentially 3 feet deep, would engulf Colorado, Utah, and Wyoming. Darkness would descend upon vast regions. Even the heavily populated coastal areas wouldn't escape, grappling with the widespread ash cloud. Think of the devastation. Crops obliterated, pastures poisoned, power lines severed, and electrical transformers ruined. It's a stark reminder of the immense power that lies beneath our feet. Thankfully, such a disaster isn't anticipated anytime soon. We already have enough on our plates, don't we? But let's turn our attention to another dramatic event, one that unfolded in 2018. It was the largest active underwater eruption ever recorded, a spectacle witnessed in the depths of the western Indian Ocean, off the coast of Madagascar. Scientists, tracking a series of earthquakes, observed over 11,000 tremors striking the small island of Mayotte between 2018 and 2021. The most powerful of these registered a magnitude of 5.9. Prior to this, the area had been remarkably quiet, with only 2 earthquakes recorded over the preceding half-century. But these weren't just ordinary earthquakes. There were also unusual seismic hums, low-frequency tremors emanating from deep underground. Too faint to be felt on the surface, these hums were detected by researchers around the globe who recognized them as indicators of volcanic activity. Unbeknownst to anyone at the time, this underwater eruption was giving birth to a colossal, skyscraper-sized volcano. This new underwater giant towered at roughly 1.5 times the height of One World Trade Center in New York, and nearly 10 times the size of the Statue of Liberty. In 2014, the area had been surveyed and found to be a relatively flat, unremarkable seabed. Now, a massive volcano stood nearly 8,500 feet below sea level. This volcano draws its magma from an incredibly deep reservoir located approximately 34 miles underground. It's the deepest known reservoir of volcanic magma on our planet. Consider the Earth's structure. It's composed of layers, with a middle layer that's often described as resembling the peanut caramel filling of certain chocolates. Research suggests that massive chunks of oceanic crust may be embedded deep within the Earth's liquid mantle, creating large, disruptive lumps in what should be a smooth layer. Our planet has a rigid outer layer encompassing a hot upper mantle and a fractured crust. The hot mantle is in constant motion, churning and driving the movement of the crust above. This process leads to the oceanic crust diving into the depths, giving rise to immense magma plumes that surge towards the planet's surface. Scientists have even uncovered an ancient fragment of the Pacific Ocean, buried hundreds of miles beneath China. These are the ancient remnants of the Pacific seabed, pulled downwards into the mantle transition zone. This rocky slab, once the ocean floor, comprises the crust and solid portions of the upper mantle. The majority of our planet's volcanic activity occurs unseen, far beneath the ocean surface. Roughly 70% of all volcanic activity takes place in the oceans, with a significant concentration in the South Pacific, where over 100 volcanoes are packed into a relatively small area. Coastal cliffs, mountain ranges, and the soils and sediments lining valleys represent just a fraction of the rocks on our planet. The oceans conceal so much more, hidden deep beneath the surface. Beneath the Earth's crust lies the mantle, a warm, thick layer of rock in constant motion. Hundreds of miles below, there are regions where diamonds form, subjected to intense temperatures and pressures before eventually solidifying. When these diamonds reach the surface, scientists can analyze their structure, gaining insights into their formation and the processes occurring deep within our planet. Thanks to these diamonds, scientists have discovered that the mantle is surprisingly wet, potentially containing far more water than all the Earth's oceans combined. Our planet is, in essence, consuming its own oceans. As tectonic plates shift, they subduct, dragging vast quantities of water into the Earth's interior. This water, trapped beneath the surface, can contribute to magma formation and lubricate faults, potentially increasing the likelihood of earthquakes. Water is stored within minerals, becoming integrated into the planet's crust during the formation of new oceanic plates. These plates undergo bending and cracking as they subduct beneath other plates, allowing enormous amounts of water to penetrate deep into the crust and mantle. Research conducted in areas 18 miles beneath the surface has revealed that these zones draw in 3 billion teragrams of water, an amount exceeding 2 billion pounds. It's a hydrological cycle on a scale almost impossible to comprehend. The ocean is like, imagine descending into an alien realm, a world hidden beneath the waves. Here, in the crushing darkness of the deep ocean, lie landscapes of unparalleled strangeness. We see magnificent underwater waterfalls cascading into abyssal lakes and rivers, a spectacle unseen by human eyes until recently. These aren't your typical bodies of water. They're formed by seawater seeping through thick layers of salt, dissolving the mineral and creating immense brine-filled pools. The dissolved salt makes the water incredibly dense, causing it to settle and form these bizarre underwater rivers and lakes. But the ocean floor is more than just strange bodies of water. Colossal mountain chains rise from the depths, and trenches yawn into the abyss. Consider the canyon in the Bering Sea, a staggering geological feature boasting over 8,500 feet of vertical relief. Suddenly, the Grand Canyon seems almost quaint in comparison, dwarfed by this submerged giant that plummets nearly 2,500 feet deeper. The deep ocean is a realm of extremes. While the average temperature hovers around a frigid 4 degrees Celsius, 40 degrees Fahrenheit, pockets of superheated water exist near hydrothermal vents. These are essentially hot springs located along the edges of tectonic plates, spewing out water that can reach a scorching 400 degrees Celsius, 750 degrees Fahrenheit. The immense pressure at these depths, a pressure no human could withstand unaided, prevents the water from boiling outright. On average, the ocean's depth is a staggering 2.3 miles. Sunlight penetrates only a fraction of this distance, reaching a mere 3,280 feet in diminishing amounts. Below that point, eternal darkness reigns. The truly illuminated portion extends only to about 600 feet. While the sun bathes part of our world in light, the vast majority of our planet, covered by over 70% water, remains shrouded in perpetual night. And the ocean isn't just a place of visual extremes, it's also a realm of immense power. The loudest sound ever recorded originated from an ice quake in the ocean. This cataclysmic event generated a sound so intense that it was detected by sensors over 3,000 miles away. Seismic activity caused a massive fracture in the frozen ground, a testament to the raw force locked within our planet. The Antarctic ice sheet, larger than the continental United States and Mexico combined, holds unimaginable quantities of water. A single large iceberg can contain over 20 billion gallons, enough to supply 1 million people for 5 years. Interestingly, humans can, under specific circumstances, drink melted sea ice. As the ice ages, the brine trapped between the ice crystals drains away, leaving behind water that is fresh enough to consume. However, were all the ice sheets and glaciers on Earth to melt simultaneously, sea levels would rise by a catastrophic 260 feet, just shy of the Statue of Liberty's height or about the height of a 26-story building. The ocean holds secrets not just in its depths, but also within its creatures. Ancient clams, those seemingly simple mollusks, can live for over 500 years, offering us a glimpse into the ocean's past. Just as we read a tree's history in its rings, we can examine the rings within a clam's shell to determine its age. This method also provides invaluable data to scientists studying ocean climate and environmental conditions over centuries. Clams can give us a snapshot of what the ocean was like 1,000 years ago. In a relatively recent development, the Earth has been recognized as having 5 oceans, not 4. The Southern Ocean, officially recognized only recently, encircles Antarctica and borders the Atlantic, Pacific, and Indian Oceans. For years, scientists debated whether it was a distinct ocean or simply the colder reaches of the other 3. What sets it apart are the unique conditions and the marine species that thrive there. The Southern Ocean is home to iconic creatures like leopard seals, orcas, Orcinus orca, minke whales, and emperor penguins, all adapted to the frigid, icy waters. It's also a crucial habitat for krill, tiny shrimp-like crustaceans that form the foundation of the food web for many larger animals in the region. The very origins of life on our planet may be intertwined with the ocean's depths. Life emerged on Earth approximately 3.5 billion years ago. While the precise mechanisms remain a mystery, some theories propose that life originated in the deep ocean. A few years ago, scientists discovered microscopic tubes and filaments within rocks formed around 4 billion years ago. These rocks are fragments of ancient oceanic crust, and the tiny structures resemble microbes found near hydrothermal vents today. The hypothesis is that these early living cells found refuge and sustenance within the rocky pores of these hydrothermal vent chimneys, sparking the incredible journey of evolution on our planet. But the ocean's depths aren't the only source of prehistoric anxiety. The Earth's largest and most dangerous supervolcanoes are stirring. When one of these behemoths erupts, the consequences will be felt globally, even thousands of miles from the epicenter. Scientists are concerned that we may not be adequately prepared to handle the fallout from such a cataclysmic event. For example, volcanic activity is brewing near Naples, Italy, but it's not from the famous Mount Vesuvius. This threat is from a less obvious volcano, one that lacks the classic peak of Vesuvius, making it a more insidious danger. But don't let its seemingly small size fool you. This geological feature could be far more dangerous than its gigantic neighbors. It possesses a vast caldera, measuring approximately 8 meters in width. This volcano is known as Campi Flegrei, and it's one of the largest volcanoes in Europe, slumbering beneath the town of Pozzuoli. Imagine, 39,000 years ago, Campi Flegrei erupted with a cataclysmic force. The eruption was so immense that ash spread across the entire Mediterranean region. Moreover, it triggered a temperature plunge of over 16 degrees Fahrenheit across Eastern Europe. This was the most significant volcanic event to occur in Europe in 200,000 years. Since that colossal eruption, Campiflegrei has experienced smaller eruptions, the most recent of which took place in 1538. Today, the area is characterized by numerous small craters, steaming hot springs, and bubbling pools. All clear indications that this volcano remains very much alive and is brewing something beneath the surface. Since the early 2000s, the ground within the massive caldera and the adjacent town has been gradually rising at a rate of approximately 1 to 1.5 inches each year. There have been at least 150 earthquakes that have shaken this supervolcano in recent times. In May 2024, a 4.4 magnitude earthquake struck the area, the strongest in the past 40 years. Residents were forced to evacuate their homes and set up camp outdoors, fearing further seismic activity. No one can predict how Campiflegrei will behave in the months and years ahead. However, authorities are conducting evacuation drills to prepare the population just in case the unthinkable happens. This Italian volcano may seem like a harmless kitten when compared to true giants like Yellowstone. For a volcano to earn the title of supervolcano, it must be capable of producing eruptions on a catastrophic scale, ejecting enormous quantities of magma, ash, and volcanic gases. The Yellowstone giant certainly meets these criteria. Although it grumbles from time to time, the Yellowstone supervolcano hasn't experienced a major eruption in 640,000 years. But when it awakens, the eruption could unleash incredible power, equivalent to the energy output of 10 massive nuclear power stations. Deep beneath Yellowstone lies a superheated zone filled with molten rock, known as magma. As more and more magma accumulates in a vast underground space called a magma chamber, the ground above begins to swell and rise. Conversely, when the magma cools, the ground subsides. Between 2004 and 2009, the ground at Yellowstone rose by nearly 10 inches, but then began a slow descent in 2010. Scientists remain uncertain as to whether an eruption is imminent. Another major volcano, Long Valley in California, has been active since 1980 and represents a significant threat. Scientists studying this supervolcano discovered that prior to its massive eruption 760,000 years ago, the buildup may have taken less than a year. This is alarming news, as a supervolcano eruption can have a devastating global impact. Consider the eruption of the Toba volcano in Sumatra approximately 74,000 years ago. This was the largest volcanic eruption the Earth had witnessed in 28 million years. It blanketed parts of Indonesia, India, and the Indian Ocean with a thick layer of volcanic debris, almost like a 6-inch blanket. The volume of rock ejected was equivalent to stacking nearly 3 million Empire State Buildings. The immense caldera it left behind is still visible from space. All the ash and gases propelled into the atmosphere blocked a significant portion of sunlight, triggering a volcanic winter that lasted approximately 6 to 10 years. Some scientists believe this eruption may have even impacted early human populations. Around the time of the Toba eruption, the human population experienced a sharp decline, with far fewer individuals surviving. Some propose that this is why all modern humans are descended from a small group of survivors. According to the Toba catastrophe theory, most early humans in Europe and Asia perished in the cold, harsh climate that followed the eruption. However, a fortunate group in Africa managed to survive. Not all scientists agree with this theory, and some archaeological and climate records present a different narrative. Another volcano that dramatically altered the world was Mount Tambora in 1815. The subsequent year became known in history as the year without a summer. It was a time of cold and relentless rain, with snow and frost even during the summer months, particularly in Europe and North America. This phenomenon was caused by the massive amounts of sulfur dioxide released into the atmosphere by the volcano, which spread globally and lowered the planet's temperature. When Tambora erupted, it generated enormous tsunamis that decimated coastal settlements and claimed the lives of approximately 10,000 people. In the aftermath, an estimated 80,000 more people died due to the far-reaching consequences of the eruption. The unusually cold weather devastated crops, leading to soaring food prices. Because horses were the primary mode of transportation at the time, the cost of oats, their feed, also skyrocketed. Some historians even suggest that this crisis indirectly led to the invention of the bicycle in 1817 as a new, more affordable means of getting around. Imagine a world plunged into twilight. The colossal eruption of Mount Tambora cast a chilling veil over the earth, triggering a 3-year-long winter. Yet, another volcanic titan in Indonesia was about to steal the scene. This was Krakatoa. In 1883, news traveled by telegram and newly emerging photographs, amplifying the impact of Krakatoa's cataclysmic event. Its final earth-shattering blast became the loudest sound ever recorded in human history. The roar reverberated across 10% of the planet's surface, an unimaginable sonic boom. The eruption unleashed a monstrous tsunami, with waves reaching half the height of the Statue of Liberty. Now, picture this. We have only a year to prepare for a supervolcano eruption. The task of stockpiling enough food and resources feels almost insurmountable. But hold on, don't succumb to panic just yet. Supervolcano eruptions are exceedingly rare. The last one occurred approximately 26,500 years ago in New Zealand. Scientists estimate that these colossal events occur, on average, once every 100,000 years. The unsettling truth is that Earth doesn't adhere to a predictable schedule. Super eruptions might cluster together, separated by shorter intervals, followed by extended periods of dormancy. Given that 2 super eruptions have already transpired within the last 100,000 years, the possibility of another one looms larger than we might expect. And consider this. While we often focus on well-known potential eruption sites like Yellowstone and Long Valley, less obvious hotspots exist. In Chile, Laguna del Mal, a volcano with a history of massive eruptions that left a vast crater, has been exhibiting alarming activity. Over the past 2 decades, the ground has been swelling at an astonishing rate, rising almost a foot each year. While some fear this could foreshadow a major eruption, scientists believe the magma accumulation is currently insufficient to trigger a supereruption. In Bolivia, the Uturuncu volcano is also under close observation. It's part of a volcanic chain responsible for past supereruptions. Since the 1960s, the land surrounding Uturuncu has been steadily rising. However, its last eruption occurred a staggering 250,000 years ago. Despite the rising magma, the consensus is that there's no immediate cause for alarm. The probability of a supereruption occurring within our lifetime is estimated at a mere 1 in 1,400, a seemingly insignificant number. But remember, someone wins the lottery every week, defying astronomical odds. A supereruption could indeed happen in the future, and when it does, we must be prepared. Surprisingly, the most extensive volcanic region on Earth isn't in Africa or Japan, but concealed beneath the icy expanse of Antarctica. Scientists have identified 138 volcanoes in West Antarctica. Should these behemoths awaken simultaneously, the consequences would be catastrophic. The melting of colossal ice sheets would inundate the oceans, causing sea levels to rise dramatically, potentially rendering the planet uninhabitable for humans. But before you hastily pack your bags for an exodus to another planet, consider this. Only 2 Antarctic volcanoes are currently classified as active. A sustained series of eruptions, spanning decades, would be necessary to inflict a truly global impact. Mount Erebus, one of Antarctica's 2 active volcanoes, proudly claims the title of the world's southernmost active volcano. It has been in a continuous state of eruption since at least 1972, emitting plumes of gas and steam, and occasionally spewing forth rocks in what scientists term strombolian eruptions. One of its most remarkable features is a lava lake nestled within one of its summit craters, a swirling pool of molten material. Such lakes are rare, requiring specific conditions to prevent the surface from freezing over. The second active volcano is Deception Island, a horseshoe-shaped landmass that forms the caldera of an active volcano. Its last eruption occurred over 50 years ago, and scientists monitoring its activity believe it's unlikely to erupt anytime soon. Antarctica also boasts numerous fumaroles, volcanic vents that release gases and vapors into the atmosphere. Under the right conditions, These vents can eject enough material to construct fumarolic ice towers, reaching heights of up to 10 feet. Scientists maintain a watchful eye on Antarctic volcanoes using seismometers, which detect ground tremors indicative of volcanic activity. They also employ more sophisticated technologies, but the remote location and harsh conditions of this polar region make monitoring exceptionally challenging. Consequently, predicting when a currently dormant volcano might awaken remains an elusive task. However, we can glean insights into the potential consequences of such an awakening by analyzing events from nearly 20,000 years ago. Around that time, Mount Takahe, a sleeping Antarctic volcano, underwent a series of eruptions, releasing substantial quantities of halogens, compounds rich in ozone. Some scientists theorize that these eruptions warmed the southern hemisphere, triggering glacial melting and contributing to the end of the last ice age. For a similar event to transpire today, we would need a series of eruptions releasing halogen-rich substances from one or more Antarctic volcanoes. The impact on our planet could be significant, a chilling reminder of the powerful forces slumbering beneath the ice. Imagine a world where the icy grip of Antarctica isn't quite as frozen as we believe. Beneath the seemingly endless white expanse, a geological drama may be unfolding. What if several volcanoes, currently hidden beneath the thick ice, were to awaken? It's a scenario that sounds like science fiction, but given the Earth's volatile past, it's not entirely beyond the realm of possibility. These subglacial volcanoes, shrouded in mystery, possess the potential to unleash more than just molten rock. Their heat could melt colossal caverns at the base of the ice sheet, generating substantial quantities of meltwater. The West Antarctic ice sheet, unique in its wet base, would then become a slippery slope, as this meltwater acts as a lubricant, nudging the overlying ice into motion. While a single volcanic eruption might seem insignificant against the sheer volume of ice, a series of eruptions occurring near the major ice streams of West Antarctica could trigger a cascade of consequences. These ice streams, the frozen rivers that funnel Antarctic water into the ocean, could accelerate, dumping unprecedented amounts of water into the sea. As the ice thins, further eruptions become more likely, a dangerous feedback loop that scientists term a runaway effect. We've seen similar events unfold in Iceland, where volcanic activity surged as glaciers retreated at the close of the last ice age. So, what would it take to spark a major Antarctic meltdown? A confluence of powerful volcanoes, releasing halogen-rich gases, all erupting within decades of each other and maintaining their intensity for centuries. Consider the stakes. Antarctica holds approximately 80% of the world's fresh water. If it were to melt entirely, global sea levels would rise by nearly 200 feet. A scenario that would force us to contemplate finding a new home planet. However, the more probable outcome involves eruptions lubricating the ice streams, gradually seeping water into the ocean. Not the end of the world, but a significant challenge nonetheless. But let's not dismiss the potential for a truly catastrophic event, a supervolcano. These geological titans have reshaped our planet in the past. Over 200 million years ago, the world underwent a radical transformation, fueled by not one, not two, but four massive volcanic eruptions. The culprit, the Central Atlantic Magmatic Province, or CAMP, a supervolcano that erupted repeatedly for an astounding 600,000 years. Imagine Rangelia, a vast landmass encompassing parts of modern-day British Columbia and Alaska, sitting atop this colossal volcano. It wasn't just lava and ash that wreaked havoc. The eruptions triggered a surge in carbon levels, fundamentally altering the planet's climate. Ironically, this period of intense volcanism might have played a role in the rise of the dinosaurs, transforming them from cat-sized creatures into the giants we know and love from Jurassic Park. The eruptions ushered in a 2-million-year rainy season, creating a hot, humid world that dinosaurs thrived in. Scientists have pieced together this ancient history by analyzing sediment layers from beneath an ancient lake in Asia. They discovered traces of volcanic ash, mercury, and carbon signatures indicating massive spikes in carbon dioxide. The atmosphere became superheated, and torrential rains fell relentlessly. The sobering reality is that another such eruption could happen again. The supervolcano lurking beneath Yellowstone National Park has been dormant for nearly 70,000 years. But if it were to awaken, the consequences would dwarf the 1980 eruption of Mount St. Helens, considered the most disastrous volcanic event in U.S. history. That eruption, triggered by months of earthquakes and magma injection, obliterated the mountain's north face. The eruption column soared 80,000 feet into the atmosphere, blanketing 11 U.S. states and several Canadian provinces in ash. Now imagine an eruption 1,000 times greater. That's the scale of Yellowstone's potential. Yellowstone sits atop a hotspot, a plume of molten and semi-molten rock called magma. This magma flows into a chamber located 4 to 6 miles beneath the park, causing the ground to swell like a balloon. As the magma cools, the ground subsides. Volcano watchers have been monitoring Yellowstone for over a century. They observed a ground uplift of about 10 inches over a 20-year period, but since 2010, the ground has been receding. Experts assure us that a major eruption isn't imminent, but ongoing underground activity keeps them vigilant. Since humans haven't witnessed the full spectrum of Yellowstone's behavior, predicting its future is a challenge. The volcano has experienced epic eruptions roughly every 600,000 to 800,000 years over the past couple million years. The last major event. Imagine traveling back nearly 640,000 years. The world looked very different then, and a cataclysmic event was about to reshape a vast landscape. We're talking about a colossal eruption, one that spread ash and debris as far as modern-day Louisiana. Even now we can witness the lingering effects of that ancient explosion within the Yellowstone caldera. Experts assure us that a repeat of such a massive eruption is unlikely. More probable are eruptions of steam, hot water, or lava flows. But the timing and intensity of Yellowstone's next awakening remain a mystery, a question mark etched in the Earth's fiery heart. When we consider active volcanoes, the Pacific Ocean's ring of fire immediately springs to mind. A staggering 3/4 of the world's volcanoes reside within this volatile belt. Compare that to a place like Australia, a continent largely devoid of volcanic activity. Even the old continent of Europe seems relatively calm, or at least we like to think so. But can you guess which volcano holds the title of Europe's most active? If Mount Etna, perched on the island of Sicily in Italy, came to mind, you're absolutely right. This fiery giant has erupted approximately 200 times and has been anything but dormant in recent decades. The most recent episode occurred in August 2023. This Mediterranean behemoth has stood for 500 million years. But Iceland boasts a much younger upstart. On July 10, 2023, this new volcano burst into life. That afternoon, 3 fissures cracked open in the ground on a peninsula in the island's southwest. This occurred at the foot of a small mountain called Litli Hrutur. In the local language, its name means little ram. Molten lava shot high into the sky, accompanied by plumes of gas. The scientific community, however, wasn't entirely surprised. They were already aware of the volcanic zone stretching between the cities of Reykjavik and Grindavik. Its name, difficult to pronounce, is Fagradalsfjall. This area had already erupted during the previous 2 summers, ending 8 centuries of quiet slumber. In the days leading up to this latest eruption, seismologists, the scientists who dedicate their lives to studying earthquakes, recorded over 12,000 tremors. When the Earth finally split open that July, the fissures extended over 1.5 miles. By the following morning, 2 of these fissures had closed, leaving all the lava to pour forth from the remaining one. This fissure grew into an elongated cone, the classic volcano shape we all recognize. Soon, the lava filled a large crater, growing almost 100 feet tall in its first week, and it continues to grow. On that dramatic night when the eruption began, lava spread in every direction. The cinders ignited the dry moss that carpeted the surrounding landscape. Local authorities swiftly closed off the area. Toxic gases from the volcano mingled with smoke from the burning moss. Firefighters rushed to the scene, and after a week, they declared the area safe for visitors. Soon, people came from far and wide to witness the birth of Europe's youngest volcano. This form of tourism is quite developed in Iceland. Travelers journey from across the globe to witness active volcanoes. The land of fire and ice is home to over 130 volcanoes, with around 30 currently active. Now, you might be wondering, is volcano tourism safe in Iceland? The answer is yes, thanks to the country's diligent authorities who constantly research and monitor all the hotspots. The island is dotted with dozens of seismic stations. These help researchers accurately predict future eruptions. Emergency services are well versed in handling these events, quickly cordoning off danger zones. This is precisely what happened in 2010 when a volcano in the island's south, a volcano whose name proved a tongue twister for many, erupted. Eyjafjallajökull spewed a plume of steam and ash that reached a staggering 7 miles high. This was not a pleasant time for air travelers. Winds carried the enormous plume southeast toward northern Europe. Many countries closed their airspace for several days as a safety precaution. The volcano erupted in March, but the Earth had been trembling since January of that year, so seismologists knew an eruption was imminent. Regarding Iceland's youngest volcano, the tourist infrastructure is already in place. Visitors can park their cars in a designated area and embark on a 5-hour hike. This track leads to a viewing deck, bringing tourists so close to the epicenter that they can feel the heat radiating from the crater. The sight is particularly breathtaking at night. Safety is paramount. Scientists regularly create hazard maps that clearly define the boundaries of lava fields. This ensures that visitors who adhere to the rules remain out of harm's way. More than a week after the eruption commenced, a section of the crater collapsed. Lava flowed downhill, west of the volcano. This majestic, smoldering river of molten rock moves slowly. Scientists classify it as Ea-type lava. This term originates from Hawaii and describes basaltic lava with a rough, brittle surface. The flow consists of broken lava blocks known as clinkers. They fall, imagine a river of fire, a molten torrent cascading down a mountainside. We witness the birth of new land as incandescent lava flows, its surface a tapestry of textures. Where the substance runs thin, glowing crimson hints at the inferno within. Cooler regions solidify into shades of gray and black. As this molten rock inches forward, a strange symphony arises. The sound of shattering glass, a chilling reminder of the Earth's raw power. Weeks after the volcano's awakening, aerial cameras capture a bizarre spectacle. A tornado, a swirling vortex of air, dances directly above the lava flow. This isn't mere coincidence. The extreme heat generates intense updrafts, and when atmospheric conditions align, a miniature tornado is born. Scientists observed a similar phenomenon during the fiery 2018 eruption of Mount Kilauea in Hawaii. Now, let's journey to Europe's second-largest island, Iceland. Here, vast lava fields whisper the tale of a land forged in fire. Iceland sits atop a volatile junction where the North American and Eurasian tectonic plates collide. These plates, colossal slabs of rock that form Earth's outer shell, number around 20. They rest upon a sea of partially molten rock, the source of all the lava we see erupting onto the surface. Picture these plates as enormous rafts drifting on a fiery ocean. Their boundaries are zones of immense instability. When two plates grind against each other, they unleash staggering amounts of energy. Volcanic eruptions are just one consequence of this titanic struggle, pathways through which molten rock ascends to the surface. Iceland's fiery genesis began approximately 60 million years ago. The tectonic plates beneath the ocean slowly drifted apart. Over eons, countless eruptions piled lava upon the seabed, eventually creating solid ground. Ancient rock formations, remnants of this early volcanism, now lie submerged beneath the waves. As fresh lava cools and hardens, it pushes older rock away from the island's center. This explains why the oldest parts of Iceland are a mere 16 million years old, relatively young in geological terms. The island's active lava fields are even younger, some less than 1,000 years old. Scientists consider Iceland a volcanic hotspot, and with good reason. Nearly a third of all basaltic lava recorded in human history has erupted from Icelandic volcanoes. Fissure swarms like the ones preceding the 2023 eruption cover a staggering 30% of this Nordic nation. This intense geological activity explains why only a quarter of the island is habitable. Norse Vikings, the first human settlers, arrived in Iceland at the dawn of the 10th century. Nature greeted them with a spectacular display of power. Just years after their arrival, they witnessed one of the largest volcanic eruptions in recorded history. Coming from a land devoid of volcanoes, they were utterly unprepared for such a cataclysmic event. Today, Icelanders are accustomed to these fiery displays, and that's fortunate because their homeland is entering a new era of heightened volcanic activity. Volcanologists suspect that recent eruptions are merely the prelude to decades of more frequent events. The peninsula that hosts Earth's youngest volcano lies just 17 miles southwest of Iceland's capital. After a long period of dormancy, recent eruptions serve as a stark reminder that the geological forces that birthed Iceland are still at work. Recently, scientists have uncovered a fascinating link between volcanic eruptions in northern Europe and the ebb and flow of glaciers. Our planet has endured at least 5 major ice ages, extended periods of frigid temperatures that led to the expansion of massive ice sheets across northern Europe and North America. The last ice age ended roughly 10,000 years ago, and researchers are still unraveling the complex interplay between glacial periods and volcanic activity. The prevailing theory suggests that the sheer weight of these immense ice sheets disrupts the subterranean flow of magma. When glaciers retreat, the pressure is lifted, creating pathways for lava to ascend and erupt onto the surface. Suddenly, the ground trembles beneath our feet. Cracks like jagged wounds tear across the landscape. Rivers of molten rock surge down the mountainsides, accompanied by a deafening roar. Rocks and debris are hurled skyward in a chaotic ballet. Clouds of volcanic gas and ash blot out the sun, plunging the world into twilight. This isn't a scene from a Hollywood disaster film. This is the reality of a supervolcano erupting. While this particular scenario isn't expected from Mauna Loa, the world's largest volcano, when it awakens from its long slumber, the potential for devastation is immense. In 2021, scientists believed an eruption was imminent, but so far, the giant sleeps on. Seismic activity fluctuates, increasing and then subsiding. But the threat remains. That's why experts maintain constant vigilance, monitoring geological activity on the Big Island of Hawaii. The Big Island is composed of 5 volcanoes, including Kilauea, the most active on the planet, and Mauna Loa. This colossal volcano accounts for nearly half of the island's landmass. The amount of lava Kilauea emits in a single day, Mauna Loa, could spew out in a matter of hours. Imagine, if you will, a sleeping giant. Not a creature of myth, but a geological behemoth. Mauna Loa, one of the largest volcanoes on our planet. For decades, it has remained relatively quiet, a stark contrast to its smaller sibling, Kilauea, which has been known to throw fiery tantrums. But now, deep beneath the surface of the Big Island of Hawaii, something is stirring. Since its last major eruption in 1984, Mauna Loa has been in a state of slumber. However, the Hawaii Volcano Observatory has recently detected a surge in activity. Over 200 minor earthquakes rumbling beneath its massive form. This seismic activity suggests a renewed flow of magma, the molten rock that fuels volcanic eruptions. Is the giant awakening? If Mauna Loa were to erupt suddenly, the consequences could be significant. Rivers of lava could potentially reach the ocean and densely populated areas, including tourist hotspots like Captain Cook, in a matter of hours. In 1984, the last time Mauna Loa exploded to life, lava flows advanced to the very edge of Hilo, home to a University of Hawaii campus. Fortunately, residents had several weeks to prepare for the impending disaster. Today, locals are more prepared than ever. Many have assembled go bags, packed with essential documents, money, and other necessities for a swift evacuation. While past eruptions have primarily affected the summit region, some have sent lava flows cascading all the way to the ocean. And with each eruption, there's no guarantee of the magnitude of its power. Now consider this. What is the tallest mountain on Earth? Most would answer Mount Everest. But measured from its base on the seafloor to its summit, Mauna Loa surpasses the Himalayan giant by a staggering 1,000 feet. This immense volcano is so massive that it actually causes the Pacific plate upon which it rests to depress under its colossal weight. When this geological monster erupts, scientists believe the sheer volume of lava released per unit of time could be catastrophic. Throughout recorded history, Mauna Loa has erupted with remarkable regularity, averaging an eruption every 6 years. Despite the fact that its last eruption occurred roughly 40 years ago, experts are certain that it will erupt again. It's not a question of if, but when. But let's dispel a common misconception. Remember that scene of a catastrophic eruption at the beginning? While dramatic, that's not likely to be Mauna Loa's style. The volcanoes of the Big Island, including Mauna Loa, are classified as shield volcanoes. This designation comes from their broad, gently sloping shape, resembling a warrior shield laid flat. Shield volcanoes are formed by highly fluid lava that flows easily over vast distances. This results in thinner, more extensive lava flows compared to the eruptions of stratovolcanoes, those tall, cone-shaped mountains like the infamous Krakatoa in Indonesia. So, when, or rather, if, Mauna Loa erupts, expect less ash and debris and more flowing lava. Because Mauna Loa is a shield volcano, its lava is exceptionally fluid and voluminous, allowing it to travel great distances at considerable speed. Using theoretical vent maps, the experts at the Hawaii Volcano Observatory have developed detailed charts of potential lava flow paths. They are particularly concerned about the recent increase in earthquake activity, which suggests that magma is actively moving beneath the surface. The occurrence of 500 to 600 earthquakes per day is a serious cause for vigilance. However, this heightened activity doesn't automatically guarantee an imminent eruption. About a decade ago, a similar surge in earthquakes signaled significant underground activity, but instead of an eruption, half of the volcano simply shifted slightly to the south. This movement likely created more space for the magma to accumulate beneath the surface. Now let's return to that catastrophic eruption we witnessed earlier. That kind of explosive event is characteristic of supervolcanoes. These are volcanoes that have, at least once in their history, unleashed an eruption with a volcanic explosivity index, VEI, of 8, the highest value on the scale. Supervolcanoes are often immense, lacking the traditional cone shape because they are essentially the remnants of colossal magma chambers that once exploded with unimaginable force, leaving behind vast calderas. These behemoths are typically situated over hotspots in the Earth's mantle. Supervolcanoes are capable of producing super eruptions, events that eject over 240 cubic miles of ash, molten rock, and searing hot gases into the atmosphere. To put that into perspective, just 4 super eruptions could completely fill the Grand Canyon. Supervolcanoes form when immense quantities of superheated magma attempt to escape from deep within the Earth. This magma rises towards the surface but fails to break through the crust. As a result, a massive, pressurized reservoir of bubbling magma accumulates at a relatively shallow depth of only a few miles. The pressure continues to build as more magma attempts to reach the surface, until finally a super eruption occurs. The most recent super eruption occurred in New Zealand, approximately 26,500 years ago. During this event, a supervolcano beneath Lake Taupo ejected over 300 cubic miles of material into the atmosphere. Along the west coast of North America lies a geological danger zone known as the Cascadia Subduction Zone. Stretching from northern California all the way to northern Vancouver Island in Canada, this area has a history of violent seismic activity. Over the last 14,200 years, geological records suggest that at least 30 major earthquakes have rocked this region. On average, a massive quake strikes approximately every 500 years. But for an unnervingly long time, Cascadia has remained silent. This prolonged period of quiet is a source of deep concern for scientists. Their hypothesis? The area is currently locked, meaning the tectonic plates are jammed together, accumulating immense pressure. Imagine the Earth holding its breath. Eventually, a section of the seafloor could rupture with unimaginable force, shifting several feet in an instant. The resulting ground shaking might last a terrifying 5 minutes, But that's just the beginning. The sudden displacement of the seafloor would unleash a colossal tsunami, a wall of water that could relentlessly batter the coastline for a staggering 10 hours. Experts predict that if this scenario unfolds, it will constitute the most devastating natural disaster in the nation's history. The very ground beneath some inland hills could liquefy, transforming into a treacherous quicksand-like substance. This would trigger landslides and widespread collapse, obliterating roads and bridges. A staggering 620,000 buildings could suffer severe damage or complete destruction, including approximately 100 hospitals and 2,000 schools. In Washington state, residents might find themselves isolated, forced to fend for themselves for up to 2 weeks, desperately seeking food, water, and shelter. Scientists are meticulously studying slow slip events, where the tectonic plates creep along at a glacial pace over weeks or months, releasing some of the pent-up energy. However, this slow release is woefully insufficient to prevent the inevitable big one. Consider this. For every single point increase on the earthquake magnitude scale, the energy released multiplies by a factor of 40. To put it in perspective, it would take approximately 1 million small earthquakes every single day for 500 years to release the equivalent energy of one massive magnitude 9 earthquake. These minor tremors, however, might offer vital clues, heralding the arrival of a far more destructive event. To enhance monitoring of the Cascadia Fault, experts are engaged in detailed mapping efforts, incorporating cutting-edge monitoring technology, both on land and offshore. Scientists have secured over $10 million in funding to deploy seismic sensors and seafloor pressure gauges, all connected via a fiber optic cable stretching off the coast of Oregon. The ultimate objective: to provide timely warnings and potentially save countless lives when the inevitable megaquake strikes. A stark reminder of the raw power of nature occurred in this part of the world in 1964. A catastrophic megathrust earthquake, forever etched in history as the Great Alaska Earthquake, registered a magnitude of 9.2. Lasting for over 4 agonizing minutes, it remains the most powerful earthquake ever recorded in the U.S. and North America. The ground convulsed with such violence that it ripped open massive fissures and triggered devastating landslides in Anchorage. Countless homes, buildings, and roads crumbled, ill-equipped to withstand such immense forces. The very landscape was irrevocably altered. Near Kodiak and Hinchinbrook Island, the coastline was thrust upwards by an astounding 30 feet. Conversely, in areas like Girdwood and Portage, the ground subsided by as much as 8 feet, necessitating the costly reconstruction of roads to prevent perpetual flooding. A colossal 27-foot tsunami obliterated the entire village of Chenega. Coastal towns suffered catastrophic damage, not only from the initial earthquake, but also from the ensuing tsunamis and the infernos that ignited in their wake. For months following the main event, the region was subjected to thousands of aftershocks, a constant reminder of the geological forces at play. In August 2024, a moderate earthquake, registering a magnitude of 4.4, rattled Los Angeles. Following the tremor, the LA Fire Department conducted citywide inspections, thankfully finding no significant damage or injuries. However, in Pasadena, a city near the earthquake's epicenter, a water pipe burst within City Hall, forcing the evacuation of the building. Fortunately, the risk of a tsunami was non-existent. The best defense against panic in such situations is preparedness. Japan is one of the most seismically active regions on Earth, situated at the convergence of 4 major tectonic plates. Approximately 2,500 earthquakes are noticeable each year. As a result, the Japanese people have learned to coexist with these geological realities. A 1950 law mandated that all buildings must be capable of withstanding earthquakes up to magnitude 7 without collapsing. A subsequent update 30 years later stipulated that buildings should sustain only minor damage during such events, remaining fully functional. But in the face of even stronger earthquakes, the primary objective shifts. The building's paramount duty is to remain standing, safeguarding the lives within. At the most fundamental level, buildings are fortified with thicker beams, pillars, and walls, designed to better absorb the energy of ground shaking. Another common technique involves the installation of specialized pads constructed from materials like rubber at the base of the structure. Some buildings are even erected upon thick layers of padding, completely isolating them from the ground, providing enhanced protection during seismic events. A skyscraper might sway dramatically during an earthquake, potentially shifting up to 5 feet. To mitigate the risk of structural damage, engineers often incorporate dampers every few floors, extending all the way to the top of the building. These dampers function like enormous bicycle pumps, absorbing and dissipating the earthquake's energy. Imagine, if you will, 500,000 Great Pyramids of Giza suddenly ascending into the sky all at once. That gives you a sense of the absolutely staggering power unleashed during certain volcanic eruptions. But what made the Toba supervolcano's eruption so peculiar, so perplexing to scientists? Well, it didn't quite follow the typical volcanic playbook. Initially, the scenario seemed familiar. Beneath the Earth's surface, a colossal magma chamber, spanning over 200 square miles, was swelling, pressure mounting relentlessly. The Earth groaned. Finally, the rock fractured, and the initial surge of molten rock erupted from the crater. But then, inexplicably, the supervolcano paused, took a chilling break. Several months later, the cataclysmic eruption finally detonated. The ground convulsed as thousands upon thousands of tons of lava, rock, and ash were hurled skyward, reaching the very upper atmosphere. This was an event of unimaginable scale. But the era of supervolcanoes is far from over. Perhaps the most infamous of these geological titans lies beneath Yellowstone National Park. This sleeping giant has unleashed at least 3 mega eruptions and countless smaller ones throughout its history. Should this monster erupt with the same ferocity as it did 2.1 million years ago, it would eject over 588 cubic miles of scorching material. To truly grasp the scale, envision 65 million Capitol buildings from Washington, D.C., all fused together into a single immense mass. That's the volume we're talking about. Fortunately, scientists currently believe that Yellowstone poses no immediate threat. For an eruption to occur, the magma within the caldera must be at least 50% molten. Currently, that figure stands at a mere 5 to 15%. Of course, Yellowstone isn't the only supervolcano lurking on our planet. We also have New Zealand's Lake Taupo, the Aira caldera in Japan, California's Long Valley caldera, and Indonesia's Toba, any of which could potentially unleash a super eruption one day. Then there are the so-called supervolcanoes that haven't yet lived up to their name, never having produced a true super eruption. Take, for instance, the Indonesian volcano Krakatoa. In 1883, it erupted with such force that it tore the volcano's walls asunder. Frigid seawater rushed into its molten heart, and the extreme temperature difference triggered a catastrophic explosion. The deafening boom was heard over 2,000 miles away in Australia, earning it the title of the loudest sound in recorded history. Yet despite the truly catastrophic consequences, it still wasn't powerful enough to qualify as a super eruption. Now, imagine rocks cascading down the slopes of a restless volcano, gathering momentum, and eventually plunging into the ocean in a colossal cascade. This is precisely what could happen if the Helena slump on Hawaii's Big Island were to detach and slide into the sea. The Kilauea volcano is far from dormant, with its most recent eruption occurring in 2018. These eruptions are often accompanied by earthquakes of varying magnitudes. With each tremor, the magma rocks on the volcano's slopes shift downwards. These rock formations are known as slumps, and the Helena slump is the most infamous of them all. In 1868, the movement of this slump triggered a tsunami that reached a staggering 60 feet in height. But even more concerning is the fact that, roughly 110,000 years ago, a landslide in this very area triggered one of the most powerful earthquakes ever recorded, which in turn spawned a mega tsunami exceeding 1,000 feet in height. Scientists are understandably concerned that such an event could repeat itself in the future. Should that happen, the resulting wave could engulf the entire Hawaiian archipelago and easily reach the coastlines of both North and South America. Geologists are quick to reassure us that a landslide of this magnitude is unlikely to occur in the immediate future. But when it does finally happen, The consequences will be nothing short of catastrophic. Yellowstone National Park, nestled in the western United States, is renowned for its breathtaking scenery, particularly the vibrant Grand Prismatic Spring. However, it's crucial to remember that Yellowstone is, first and foremost, an enormous caldera, essentially, a slumbering supervolcano. The key difference between a regular volcano, such as Kilauea, and a supervolcano lies in the sheer magnitude of their power. Supervolcanoes are thousands of times more potent. Imagine a regular volcanic eruption spewing tons of massive rocks, rivers of molten lava, and billowing clouds of ash that ground air travel for weeks. Now, amplify that scenario 1,000-fold. That's a glimpse into what a Yellowstone eruption would entail. Initially, a vast area in the heart of the national park would tremble, fracture, and then explode upwards in a megaton blast. Lava flows and magma rocks would blanket an area of approximately 40 square miles, roughly half the size of Washington, D.C. But the most pervasive danger would be the volcanic ash. The immense ash plume would ascend miles into the atmosphere, carried by the winds in every direction. Since the eruption, imagine a world plunged into darkness, not by night, but by a choking cloud of ash. A supervolcano erupts, dwarfing any eruption in recorded history. The scale of destruction is almost unimaginable. The immediate devastation would be catastrophic, but the true horror lies in the aftermath. The ash, thick and heavy, blankets everything, smothering crops and collapsing buildings. But the danger doesn't stop there. This ash ascends into the atmosphere, a dark veil blotting out the sun. Temperatures plummet, ushering in a prolonged artificial winter. Even regular volcanic eruptions can nudge global temperatures down a few degrees. A supervolcano, however, possesses the potential to trigger a new ice age. Fortunately, the likelihood of the Yellowstone supervolcano unleashing its fury in the immediate future, or even at all, remains exceedingly low. Throughout Earth's history, only 3 such cataclysms have been documented. Scientific models place the probability at a mere 0.4%, a figure lower than the odds of a planet-killing asteroid impact. Speaking of asteroids, if dinosaurs could somehow offer their perspective, they would undoubtedly emphasize the very real threat posed by these celestial wanderers. Scientists at NASA diligently track approximately 90% of near-Earth asteroids of significant size. Reassuringly, none of these pose an immediate threat. However, the remaining 10% lurk in the uncharted cosmic depths. Furthermore, an asteroid's trajectory can be altered by the gravitational tug of other celestial bodies, potentially sending it hurtling toward our planet. Picture this: an asteroid, a mile across, slams into Earth. The initial impact generates an explosion with the force to obliterate a dozen major cities in mere seconds. A colossal cloud of dust and debris billows skyward, mirroring the volcanic ash cloud, plunging the planet into a centuries-long winter. Even if the asteroid were to fall into the ocean, a more likely scenario, the resulting tsunami would be of unimaginable scale, a wall of water several miles high, engulfing coastal cities. While this oceanic impact might avert a full-blown ice age, the devastation would be almost incomprehensible. Although scientists currently believe that no such asteroid threat looms in the immediate future, they cannot entirely dismiss the possibility. Humanity would require at least 5 years to adequately prepare for such an event should a large near-Earth asteroid suddenly alter its course and set a collision course with our planet. It would be a disaster movie playing out in reality. A more probable calamity, however, lies directly beneath our feet. The San Andreas Fault in California. The fault line has been primed for rupture for years. Scientists estimate that a major earthquake along this fault is highly probable within the next 3 decades. And when it occurs, the consequences will be severe. Experts predict a magnitude of 8.0, rivaling some of the most devastating earthquakes in recorded history. The danger is amplified by California's dense population, home to major cities like Los Angeles and San Francisco. High-rise buildings, common in these urban centers, are particularly vulnerable to the destructive forces of underground tremors. The San Andreas earthquake could inflict widespread damage on both urban and rural landscapes. In the most extreme scenario, the ground could fracture, tearing apart buildings and farms, permanently altering the landscape. Yet, scientists estimate the probability of such a quake at only 7% for the next 30 years, leaving a 93% chance that we may never witness such an event in our lifetimes. Another significant earthquake hazard exists not far from California, the megathrust fault in Chile. The country sits directly above a subduction zone, a region where two tectonic plates converge, one sliding beneath the other. This continuous movement generates immense stress. When the accumulated strain exceeds the limit, a major earthquake is unleashed. Chile has experienced numerous earthquakes in recent years, leading scientists to believe that the region may be on the verge of a truly massive event. Geologists anticipate a great earthquake will strike before the end of the century, potentially devastating coastal areas. Even smaller quakes trigger tsunamis that inundate the west coast. A massive earthquake would likely generate a wave of unimaginable height. On the positive side, Chile has learned to prepare for these natural disasters, and geologists are confident that people will be able to evacuate before the earthquake strikes. Now, let's journey back to September 1st, 1859. Astronomer Richard Carrington was observing the sun when he witnessed a sudden brilliant flare erupting from its surface. He meticulously recorded the event in his notes, but only realized its significance days later. The energy from that solar flare reached Earth, striking it directly. This caused auroras, the northern lights, to appear as far south as Cuba and disrupted telegraph lines worldwide. This event, known as the Carrington event, was a solar storm of unprecedented intensity. Such storms frequently bombard Earth, but none have matched the sheer power of the Carrington event. Imagine the impact of a similar event today on our modern technology-dependent world. Imagine a cosmic event, unseen yet potentially devastating. Picture the year 2012. Astronomers scanning the heavens detect a solar flare, a colossal eruption of energy from our sun. This event, similar to others recorded, narrowly misses Earth. Had it struck just a week earlier, the consequences would have been catastrophic for modern civilization. Humanity's reliance on electricity is absolute. A solar storm of sufficient magnitude would wreak havoc on Earth's electromagnetic field. Across the globe, electrical appliances would fail, either shutting down entirely or suffering irreparable damage. Massive transformers, the backbone of our power grids, would be destroyed. Repairing or replacing these critical components would take years, and the economic cost of such a widespread blackout would be measured in trillions of dollars. The chilling reality is that science remains largely unable to predict these solar storms. Even with advance warning, we are essentially powerless to stop them. The flare itself occurs in mere seconds. It takes approximately 8 minutes for the initial wave of particles to reach Earth's atmosphere, causing the first disturbances. The true chaos, the widespread power outage, would follow a day or so later as a massive cloud of plasma engulfs our planet. Currently, no effective protection exists against solar flares of this magnitude. The probability of a flare, powerful enough to cripple our electrical infrastructure within the next few years, is surprisingly high, estimated at around 12%. The silver lining is that awareness of this threat allows us to at least prepare. Perhaps stocking up on essentials like, well, humans may sit atop the food chain, but we are not immune to trouble. Consider the New World screwworm fly. These flies, with their distinctive red eyes and iridescent blue-green bodies, are a persistent nightmare for farmers across the Americas. For centuries, these tiny troublemakers have plagued livestock from Florida to California, causing immense damage to the agricultural industry. To combat this persistent threat, the United States Department of Agriculture embarked on an ambitious program. They released a staggering 15 million sterile screwworm larvae from helicopters along the Panama-Colombia border. A dedicated facility in Panama churns out these sterile larvae as if they were factory-fresh produce. This action might sound bizarre, but it is rooted in sound biological principles. Female screwworm flies mate only once in their lives. If they mate with a sterile male, that is the end of their reproductive line. This clever strategy effectively prevents healthy screwworms from reproducing when surrounded by their sterile counterparts, keeping their numbers in check. But how are these male flies rendered sterile? The answer is simple: a dose of radiation. The flies are subjected to a quick spin through an X-ray machine before being released into the wild, where they mingle with their fertile relatives. If screwworms show signs of resurgence, inspectors patrol thousands of miles on ATVs, searching for infected animals and preventing further spread. There is no single magic bullet to eradicate these parasites completely. The ongoing strategy involves continuous sterile fly releases and constant vigilance to stay ahead of these pesky critters. Why is it so dangerous to move animals from one habitat to another? Imagine a scenario where a species, transplanted to a new environment, encounters no natural predators. The result? An invasive species that can trigger an ecological disaster. Consider the case of the cane toad in Australia. In the 1930s, Australian farmers faced a severe problem. Cane beetles were devastating sugarcane crops in the northern part of the country. These insects consumed vast quantities of the harvest, and conventional methods of control were failing. Unwilling to resort to harmful pesticides, farmers introduced cane toads from South America, hoping they would prey on the beetles. However, upon arriving in the cane fields, the toads discovered they could not reach their intended prey. The beetles lived on tall sugarcane stalks, beyond the toads' jumping range. Instead of beetles, the toads began consuming other insects. The amphibian population exploded. A female cane toad can lay up to 30,000 eggs at a time. Within days, tiny tadpoles hatch and, after a few weeks, transform into adult toads, capable of living for 5 to 10 years. Millions of these jumping amphibians spread across northern Australia, wreaking havoc on the local ecosystem. They consumed leaves, grass, and insects, depleting food sources for native animals. The toads proved remarkably resilient, thriving in heat, cold, rain, and drought. They bred prolifically, seemingly unstoppable. But what about natural predators? Australia boasts a diverse array of predators, including alligators and large birds, that might be expected to prey on the croaking invaders. Imagine, millions of years ago, an amphibian. But not just any amphibian, a cane toad. Yes, it's true, amphibians existed then, but any creature that attempted to make a meal of these toads often met a grim end. The problem? Cane toads are venomous. Special glands located behind their eyes produce potent toxins, causing severe health problems, even death, in unsuspecting predators. Some farmers witnessed birds collapsing mid-flight after swallowing these amphibians. More than 8 decades have passed since those farmers introduced a mere 100 KUs, cane toads, to Australia. Now, their numbers have exploded to an estimated 1.5 billion. They've already overrun 386,000 square miles, an area comparable to the combined size of Texas and Oklahoma. Despite the efforts of scientists and biologists, an effective solution to control their population remains elusive. People have tried to capture them, but the task is futile. Even if you manage to capture 98 out of 100 toads near a small pond, the remaining 2 can produce a staggering 30,000 eggs per night. Perhaps nature will eventually restore balance as animals with immunity to the toad's toxins emerge in Australia. But for now, the cane toad juggernaut seems unstoppable. But what about another pest, the mosquito? How can we halt the unchecked proliferation of these insects, notorious carriers of diseases that threaten human health? One proposed solution involves creating 735 million genetically modified mosquitoes and releasing them worldwide. Numerous mosquito species transmit infections that cause serious health problems in humans. Almost universally disliked, these buzzing insects disrupt our sleep, and their bites inflict relentless itching. Many would rejoice if these creatures vanished from the face of the earth, and scientists may have discovered a way to fulfill that wish. Only female mosquitoes bite, driven by their need for blood to produce eggs. Scientists have engineered male mosquitoes with a special protein in their bodies. Upon mating, this protein is transferred from the male to the female, preventing her from producing offspring. This occurs before the female reaches the age when she begins to bite. Consequently, the females cannot reproduce, eliminating their need to bite people and animals. As scientists disseminate more of this protein, the mosquito population should dwindle. However, this approach is not without controversy. Approximately 240,000 people have signed a petition demanding the cancellation of this experiment. Many scientists fear that the extinction of even a single insect species could trigger a biological catastrophe. Nature is a delicate balance system where even the slightest disruption can lead to severe consequences. Mosquitoes serve as a vital food source for numerous reptiles and amphibians. Their extinction could set off a chain reaction of ecological collapses, the ultimate outcome of which remains unknown. Nevertheless, modified mosquitoes have already been released in Florida, and so far, no dire consequences have materialized. The positive news is that people have reported fewer health problems following the release. Moreover, since 2019, approximately 1.5 billion of these modified mosquitoes have been released globally. This initiative has saved millions of lives and thus far has not disrupted the delicate balance of nature. Recently, scientists released another cohort of safe mosquitoes in East Africa. Let's hope that scientists have everything under control. Invasive species are not always limited to insects and amphibians. They can also manifest as larger animals, such as feral pigs, sometimes referred to as super pigs. These pigs are hybrids, a mix of domestic swine and wild boar. Currently, nearly 7 million feral hogs roam the southern United States. Thanks to human intervention, these animals have not yet spread to the north, but the northern states face an impending threat from Canada. Pigs were introduced to Canada in the 1980s to bolster agriculture. However, in the early 2000s, wild boars fell out of favor. They were simply left to roam free, and farmers were confident that these animals would not survive the harsh Canadian winters. How wrong they were. Wild pigs proved to be remarkably hardy, mobile, and capable of rapid reproduction. These animals dig and tear up the ground, consume virtually everything in their path, and thereby deprive other animals of food. Furthermore, other creatures can become their prey. Wild pigs attack mice, geese, ducks, and even some species of deer. They trample crops, grass, and flowers, and they fear nothing. They are, in effect, like natural bulldozers. Any farm that lies in the path of thousands of super pigs faces imminent ruin, and humans seem powerless to stop them. The northern states recognize that an invasion is inevitable, so they are bracing themselves for a protracted battle. Super pigs thrive in swampy areas with tall grass. Canadian and American farmers intend to drive them into more open terrain and then enclose those areas with fences. The plan is imperfect, but it may slow the pigs' advance and buy some precious time. Imagine for a moment that you're about to wrap up your workday, the weekend shimmering just beyond the horizon. You're about to hit send on that final report when a low, guttural rumble vibrates through the floor, unsettling your desk. Is it just the light rail passing by? Sadly, no. This is something far older, far more primal. It's the Earth itself, speaking through the ancient voice of a volcano. Here in Arizona? That's right. The very ground beneath your feet is shifting, reminding us that our planet is a living, breathing entity. But don't panic, at least not yet. Let's arm ourselves with some context. A staggering 20 American states harbor volcanoes. Extinct, active, and dormant giants slumbering beneath the surface. Among them, you'll find California, New Mexico, Nevada, Utah, and Colorado. The good news? Arizona's volcanoes are currently dormant, resting in a deep, geological sleep. The less comforting news? That doesn't guarantee they won't awaken in the future, whether near or distant. Now, picture this. Let's journey back in time and travel to Arizona, where we can witness the telltale scars of its fiery past. These ancient volcanic traces are scattered across the desert landscapes like freckles on a sun-baked face. There are entire volcanic fields lurking southwest of Phoenix, east of Douglas, near Flagstaff, north of Kingman, and close to the Mexican border. What's truly unsettling is that, despite their current inactivity, eruptions in these regions could occur roughly every 1,000 years. And it appears that time may be drawing near. The last major volcanic event, a powerful and destructive eruption, occurred approximately 1,000 years ago at Sunset Crater. This location is particularly noteworthy, and we'll return to it shortly. But first, let's delve into the concept of hotspots. No, not the Wi-Fi kind. In our volcanic context, a hotspot is a geological anomaly where immense heat relentlessly melts the Earth's crust, that relatively thin outer layer we call home, giving rise to volcanoes. This intense heat originates from the mantle, a region nestled between our planet's intensely hot, dense core and the crust above. Want a vivid example of this type of volcanism in action? Then let's fly to the Hawaiian Islands. The Big Island boasts active volcanoes because it currently sits directly atop the Hawaiian hotspot. The older Hawaiian Islands were once in the same position, but over vast stretches of time, they drifted northwest. This occurred because they reside on the Pacific Plate, a massive slab of oceanic crust that is constantly, albeit slowly, moving. Now, cast your gaze across the world's ocean basins. They are, quite literally, sprinkled with islands perched atop hotspots. Hawaii, Iceland, Samoa, and the Galapagos Islands are perhaps the most iconic examples. But don't assume that only oceans can host hotspots. Continents can too, although they are significantly rarer. One of the most famous continental hotspots lies beneath the Yellowstone caldera. The caldera itself is a colossal volcanic crater, often formed by a cataclysmic eruption that causes the volcano's mouth to collapse inward. The Yellowstone hotspot is essentially the architect behind Old Faithful and all the other hot springs and bubbling mud pots that make Yellowstone National Park so renowned. Speaking of Old Faithful, let's take a brief detour and focus our attention on this natural wonder. It's one of the most celebrated geysers on Earth, drawing visitors from every corner of the globe for over a century. What makes this geyser truly remarkable is that it can only form under very specific and rare conditions. Deep beneath the surface, magma superheats pockets of underground water. The pressure relentlessly builds until it finally overcomes the resistance and forces the water upward with tremendous force. A particular type of volcanic rock, rich in silica, lines the tunnel through which this scalding water escapes. This creates a unique, natural pipe capable of withstanding incredible pressure and heat generated by the erupting water. Old Faithful holds the distinction of being the first geyser in Yellowstone to be officially named. If you plan a visit expecting it to erupt precisely every hour, you'll be slightly disappointed. On average, Old Faithful erupts roughly every 91 minutes, which isn't too long to wait. Plus, you can download a specialized app that provides an estimated time for the next eruption. But remember to exercise extreme caution during your visit and maintain a safe distance from the geyser. The water erupting from this powerful force of nature reaches a scorching 204 degrees Celsius, and the steam is even hotter, reaching up to 350 degrees, 107 degrees. That's hot enough to bake a cake in mere minutes. But let's return to our exploration of volcanic hotspots. Scientists are still grappling with the reasons why hotspot volcanoes are less common on continental crust. One likely factor is that continental crust is considerably thicker than oceanic crust, approximately 4 times thicker, on average. Another contributing factor could be that the majority of Earth's crust, roughly 2/3, is oceanic. This simply leaves less continental crust available for hotspots to form beneath. Now, I bet those of you living... Let's journey to Arizona, where a geological marvel awaits. The San Francisco Volcanic Field. Imagine a sprawling landscape, a colossal canvas splashed with the remnants of over 600 volcanoes. While most are modest in size, their sheer number is breathtaking. They're scattered across a staggering 1,800 square miles of northern Arizona. A scientific debate rages. Is this volcanic field perched atop a hidden hotspot? While the jury's still out, one fact is clear. The volcanoes become progressively younger as you travel east. This pattern hints at the relentless westward march of the North American plate, grinding over a stationary hotspot simmering deep below. Fascinating, isn't it? This volcanic extravaganza began roughly 6 million years ago, a mere blink of an eye in geological terms. The most recent eruption occurred less than 1,000 years ago, birthing Sunset Crater, a prominent landmark near Flagstaff. The eruption forced the Sinagua people to abandon their homes at Wupatki Pueblo. Today, the site is preserved as Wupatki National Monument, a window into the lives of those who once coexisted with these fiery giants. Exploring the area, you'll notice the dominance of basalt cinder cones, small, steep volcanoes sculpted by ancient eruptions. The Colorado Plateau's arid climate has acted as a preservative, shielding these volcanic cones from significant erosion. Some, like the SP crater, appear almost as if they formed yesterday. But the San Francisco volcanic field is more than just cinder cones. A stratovolcano lurks among them, along with lava domes formed from silica-rich volcanic rock, a thicker, less fluid magma than the basalt found in places like Hawaii. The stratovolcano's remains are among the most impressive features of the field, the San Francisco Peaks. These majestic peaks tower over the landscape, reaching heights of over 2,600 feet. That's like stacking 4.5 Burj Khalifas on top of each other. The peaks dominate the skyline of northern Arizona. Beyond their stunning beauty, they hold deep spiritual significance for the Native American tribes who have called this area home for countless generations. Unlike the relentlessly active volcanoes of Hawaii, the San Francisco volcanic field operates on a more leisurely timescale, with thousands of years separating eruptions. However, don't let that lull you into complacency. Geologists believe another eruption is inevitable, likely in the remote eastern reaches of the field, far from major population centers. If the next eruption mirrors the formation of Sunset Crater, it will be a spectacle of nature's raw power. Lava fountains erupting skyward, rivers of molten rock snaking across the landscape. This fiery display may be centuries, even millennia, away. Until then, the San Francisco volcanic field remains a hidden treasure trove of volcanic history, patiently awaiting its next fiery performance. Now, listen closely. Do you hear those ominous rumblings? Is the ground trembling beneath your feet? Perhaps it's just your stomach. Or maybe, just maybe, it's Mount Adams in Washington state, stirring from its slumber. This is the state's largest volcano, measured by both area and volume. And after millennia of silence, it's showing signs of reawakening. Scientists have detected a worrying surge in seismic activity around Mount Adams. Its last eruption occurred between 3,800 and 7,600 years ago, a time when humanity was still in the Stone Age. This sudden increase in activity has piqued the curiosity of scientists. The U.S. Geological Survey, USGS, has swiftly deployed temporary seismic stations around Mount Adams to monitor the situation closely. At the same time, they are reassuring the public that there is no immediate cause for alarm. While Mount Adams doesn't reach the towering height of Mount Rainier, it still sprawls across a vast area, making it Washington's largest active volcano. Intriguingly, records show that prior to September of this year, Mount Adams experienced an average of only one minor earthquake every 2 to 3 years since 1982. Then, in September, the Cascades Volcano Observatory and the Pacific Northwest Seismic Network detected a staggering 6 earthquakes in a single month. These quakes were all relatively small, with magnitudes ranging from 0.9 to 2 on the Richter scale. This means they were so weak that they were imperceptible at the surface. Furthermore, satellite imagery confirmed that there was no ground deformation in the area. As of now, the USGS maintains Mount Adams alert level at green or normal. So, for now, there's no need to fear the Earth splitting open beneath our feet. Imagine a world where the very ground beneath our feet could erupt without warning. Recent seismic activity near Mount Adams has prompted scientists to install more advanced monitoring equipment. This expanded network will allow them to detect even the smallest tremors, helping them to understand the subterranean processes at play. Will this increased activity lead to a future eruption, or is it merely a random anomaly? If Mount Adams were to erupt, it would likely produce slow-moving lava flows, quite unlike the explosive eruption of Mount St. Helens. Historically, lava flows from Mount Adams have only traveled a few miles. The real danger lies in lahars, devastating mud flows created when volcanic ash, rock, and melted ice combine during an eruption. These lahars have occurred even without eruptions, as rock weakened by hydrothermal processes at the volcano's summit suddenly breaks loose. The USGS rightfully classifies Mount Adams as a high-threat volcano. Now, let's shift our focus to Iceland, where the mighty Katla lurks. This is one of Iceland's most formidable and treacherous volcanoes. It last roared to life over a century ago, in 1918. Should it erupt again, the force could be tenfold that of the Icelandic volcano, whose name is difficult to pronounce, the one that disrupted European air travel in 2010. A major eruption of Katla could unleash vast quantities of sulfur dioxide, potentially forming sulfate aerosols in the atmosphere. These aerosols could reflect sunlight, potentially causing a temporary global cooling effect, a phenomenon observed after past catastrophic eruptions. While Iceland is no stranger to volcanic activity, Katla's ash cloud would likely soar to greater heights and blanket a larger area of Europe than its notorious counterpart. Flights would be grounded, economies would suffer, and agriculture, water supplies, and air quality would all be negatively impacted. Back in 2014, scientists even suggested that a substantial eruption could trigger a tsunami that sweeps along Iceland's southern coast and out into the ocean. The precise impact of such a tsunami remains uncertain. Katla tends to erupt on a regular schedule, approximately every 40 to 80 years. This means that another eruption is statistically imminent. Let's turn our attention to the Canary Islands, where the Cumbre Vieja volcano erupted in 2021, a stark reminder of its destructive power. The lava flow was relentless, engulfing entire neighborhoods and pouring into the ocean. Over 3,000 homes were destroyed, and thousands of people were forced to evacuate. Yet, scientists believe the devastation could have been far worse. A massive eruption of Cumbre Vieja could cause the volcano's entire western flank to collapse into the Atlantic Ocean, triggering a mega tsunami. This hypothetical tsunami could generate waves hundreds, if not thousands of feet high, inundating coastlines throughout the Atlantic Basin, including parts of the US and Europe. Fortunately, recent studies suggest that a collapse of that magnitude is unlikely. However, even with the low probability of a mega tsunami, scientists emphasize the importance of preparing for potential eruptions, as the lava flows themselves pose a significant threat to human life and infrastructure on the island. Our journey now takes us to Ecuador, where Cotopaxi, one of the country's most active volcanoes, demands our attention. Since 2022, it has been exhibiting minor eruptions, but the potential for a major event keeps scientists on high alert. A large-scale eruption of Cotopaxi could produce a towering ash cloud reaching over 12 miles into the atmosphere, threatening the lives of approximately 200,000 people in the surrounding area. A particularly grave danger lies in Cotopaxi's snow-capped summit. A major eruption would cause rapid melting, leading to destructive floods and landslides that could cascade down the mountain and engulf populated areas. This combination of volcanic activity and glacial meltwater makes Cotopaxi a high-risk volcano. A powerful eruption could occur soon, or it could be years, even decades away. But continuous monitoring is in place to detect any warning signs. And finally, let's not forget the already infamous Mount Vesuvius. Imagine the year is 79 CE. The bustling Roman cities of Pompeii and Herculaneum thrive in the shadow of Mount Vesuvius. Little do the inhabitants know, a catastrophic eruption is brewing. In a matter of hours, the volcano unleashes its fury, burying the cities under ash and pumice, a tragic testament to nature's power. Centuries pass. Vesuvius slumbers, but it is not dead. Its last eruption occurred in 1944, a stark reminder of its volatile nature. Today, Vesuvius remains a restless giant, a constant threat to the sprawling metropolis of Naples. Over 3 million people live in its shadow, many dwelling on its very slopes. Should Vesuvius awaken, it would be an explosive event of unimaginable scale. Imagine the scene: ash, rocks, and volcanic gases ejected at speeds exceeding anything imaginable. While scientists believe a major eruption is unlikely in the next few centuries, Vesuvius remains one of the most closely monitored volcanoes on Earth, a potential for disaster looming over a densely populated region. Now, let's journey across the Atlantic to North America, where another formidable volcano lurks. Popocatépetl, often called El Popo, towers over the landscape, a snow-capped sentinel just 40 miles from Mexico City. Its proximity to a metropolitan area of 22 million people makes Popocatépetl an especially grave danger. Picture this. A large eruption could unleash a colossal ash cloud over Mexico City, crippling the city. The ash would infiltrate drainage systems, contaminate water supplies, and trigger widespread power outages by short-circuiting electrical systems. Furthermore, devastating lahars, rivers of mud and debris, could surge down the volcano's slopes, engulfing nearby towns. Since the early 2000s, Popocatépetl has displayed near-constant seismic activity. Minor eruptions are frequent, with 13 recorded in early 2024 alone, causing alarm among nearby residents. Volcanologists consider these eruptions normal for Popocatépetl, but the potential for a larger, more destructive event remains a chilling possibility. Of course, any discussion of super dangerous volcanoes must include Yellowstone National Park. Here lies one of the world's largest supervolcanoes, a sleeping giant beneath a landscape of geysers and hot springs. Its last massive eruption occurred approximately 640,000 years ago. If such an event were to repeat today, the consequences would be globally devastating. Imagine the scene. States closest to Yellowstone, including Montana, Idaho, and Wyoming, would face catastrophic pyroclastic flows. Scorching avalanches of lava, ash, and gases capable of obliterating everything in their path. Vast swathes of the country would be buried under volcanic ash, in some areas exceeding 3 feet in depth. On a global scale, a Yellowstone eruption would inject colossal quantities of ash and gases into the stratosphere, potentially blocking sunlight and plunging the planet into a volcanic winter. Global temperatures could plummet for years, disrupting agriculture, crippling transportation systems, and triggering widespread food shortages. Despite the popular myth that Yellowstone is overdue for an eruption, geologists emphasize that volcanoes do not adhere to precise timelines. Current activity levels do not indicate an imminent eruption, a small comfort given the magnitude of the potential disaster. Now, let's travel back in time, 40,000 years, to a Europe vastly different from the one we know today. The landscape is harsh, cold, and unforgiving. Food is scarce, and modern comforts are non-existent. Suddenly, a figure emerges from the woods. Stocky, powerfully built, with a face that is both familiar and alien. This is a Neanderthal, Homo neanderthalensis. These were no mere ancient humans. Neanderthals were a distinct human species. We, Homo sapiens, share a common genus, Homo, but Neanderthals followed their own evolutionary path, and in many ways, they were even more impressive than us. So, what happened to them? Neanderthals thrived for an astonishing 360,000 years, inhabiting Europe and parts of Asia. Then, around 40,000 years ago, disaster struck. The area we now know as southern Italy sat atop a massive supervolcano, Campi Flegrei. This colossal caldera, roughly 9 miles wide, lay dormant. But one day, it erupted in one of the most significant volcanic events Europe had witnessed in 200,000 years. Imagine the cataclysm. Ash, gases, and debris were hurled into the atmosphere, altering the climate across the entire continent. A volcanic winter descended, average temperatures plummeted, the sky darkened, and life became even more brutal. The eruption, known as the Campanian Ignimbrite eruption, caused temperatures in Europe to drop by as much as 7 Celsius. Even a single-degree decrease could trigger harsher winters, bringing devastating snowfall, torrential rains, and widespread floods. The Neanderthals, already struggling to survive in a challenging environment, faced a crisis that would ultimately contribute to their demise. Imagine a world where the very air tastes of ash, where the sun struggles to pierce through a perpetual twilight. In such a world, crops wither and die, leading to devastating food shortages. The weather itself becomes a weapon, unleashing storms of unimaginable fury. Think of the chaos we experience today, then multiply it sevenfold. This was the reality faced by the Neanderthals. But could a single volcanic eruption truly wipe out an entire species? The answer is more complex than it seems. The Neanderthals were already teetering on the brink, their existence threatened by a new rival. Us, Homo sapiens. Their strongholds in Europe, Western Asia, and the Middle East were increasingly contested. Homo sapiens, with our cunning and adaptability, proved to be formidable adversaries. We were more adept at finding food, quicker to adapt to changing environments, and masters of more advanced tools. Slowly, relentlessly, we pushed the Neanderthals out, competing for the same dwindling resources. We made their extinction a drawn-out, agonizing process. So, while the volcanic eruption undoubtedly worsened their plight, it wasn't the sole cause of their demise. And, remarkably, they didn't vanish entirely. Pockets of Neanderthals clung to existence in isolated regions, like the Crimean Peninsula, for another 12,000 years. Why did some survive? It's likely that the most severe cooling effects were concentrated further east, sparing some of the Neanderthal territories. Some scientists even theorize that the volcanic fallout may have temporarily hindered the expansion of Homo sapiens, granting the Neanderthals a brief reprieve. This eruption, a cataclysmic event, was merely a delay of the inevitable. The source of this devastation is known as Campi Flegrae, a name that translates to fields of fire. Even the air itself seems steeped in legend and dread. The ancient Greeks and Romans believed this place to be the gateway to the underworld. Virgil, the renowned Roman poet, described how his hero Aeneas descended into the underworld through this very location in the Aeneid. Once, this landscape was dotted with Roman villas, spas, and fish ponds, a playground for the elite. Little did they know they were living on a volcano, a sleeping giant capable of unleashing unimaginable fury at any moment. Campi Flegrae isn't your typical volcano with a single towering peak. Instead, it presents a deceptively calm facade of rolling hills and minor formations. But from above, the true scale of the danger becomes apparent. A colossal circular basin, scarred with volcanic cones and craters, a testament to the Earth's violent past. The danger here is subtle, insidious. The ground beneath your feet is in constant flux, shifting even when imperceptible. Periodically, the land rises and falls, sometimes by several feet, as magma and gases churn beneath the surface. It's a landscape that inspires a primal unease, a sense of invisible risk. Campi Flegrae is a vast caldera, a depression formed by two massive volcanic eruptions. One of these eruptions may have contributed to the Neanderthals' decline, while another occurred approximately 15,000 years ago. However, the most famous eruption took place in the 16th century, a truly horrifying event. The year was 1538. For years, the residents of Pozzuoli had noticed an unsettling phenomenon. Land that had once been submerged beneath the waves was slowly rising. The sea was receding, revealing new ground. Deep rumblings from within the earth had become a disturbing, yet familiar, part of their lives. Earthquakes, initially small, had begun in the early 1530s. Over the next 8 years, they intensified, becoming a constant presence. Then, on September 28th, terrifying tremors shook the ground with unprecedented force. By the evening, as the sun began to set, a massive crack tore open in the earth near the ancient Roman town of Tripergola. From this fissure erupted fire, smoke, and a torrent of volcanic ash mixed with mud and underground water. The ground heaved as hot pumice and rock were launched high into the air. A new mountain was being born, Monte Nuovo. After days, the earth seemed to take a breath. Things calmed down. Locals relaxed, drawn to the new volcano, a crater filled with what appeared to be boiling liquid. They visited it like a new attraction, but days later the disaster struck again. At night, without warning, the new mountain erupted again. A blast from the southern flank sent scoria, chunks of jagged volcanic rock, hurtling through the air. This time, the eruption was deadly, claiming the lives of 24 people. The debris left behind was enormous. For centuries after, the only signs. Imagine, millions of years ago, the Earth was a very different place. Even seemingly tranquil landscapes held simmering dangers beneath their surfaces. Consider the area near Naples, Italy. Today, it's a picturesque scene, a lush green canvas. But beneath this beauty lies a sleeping giant, the Campi Flegrae, a supervolcano. For now, Campi Flegrei rests quietly, but the question looms. For how long? There are unsettling signs that it may be stirring from its slumber. This isn't your average volcano. It's a hellish realm of boiling mud pits, hissing geysers, and ominous steam vents. It's easy to see why ancient Romans and medieval Christians believed this place was a gateway to the underworld, a direct passage to the infernal depths. What's truly unnerving is the unusual activity recently detected deep beneath the surface. In 2012, recognizing the growing threat, Italian authorities raised the alert level from green to yellow. This signifies that Campi Flegrei now requires constant, vigilant monitoring. Before a volcanic eruption, certain telltale changes often occur. The magma chamber far below begins to release tremendous amounts of gas. This process can weaken the surrounding rock, potentially triggering a catastrophic event. The problem is, predicting exactly when, or even if, an eruption will occur is impossible. The potential consequences are staggering, ranging from minor disruptions for the local population to a global disaster of epic proportions. The last minor eruption of Campi Flegrei happened in the 16th century, and while it wasn't devastating, the stakes are much higher now. If history were to repeat itself on a larger scale, as it may have with the Neanderthals, the consequences would be dire. A major eruption could trigger global cooling, widespread crop failures, and devastating famine across the planet. Currently, a dedicated team of scientists is working tirelessly to understand what's happening deep underground. The Campi Flegrei Deep Drilling Project aims to bore a 10,000-foot hole into the Earth, hoping to directly observe the magma chamber. This ambitious project seeks to provide a clearer picture of the volcano's activity and potential risks. But for now, the supervolcano remains quiet. Let's hope, for the sake of humanity, that it remains that way. The fate of millions, perhaps billions, could depend on it. The very ground we walk on holds a terrible secret, a reminder of the immense power that lies dormant beneath our feet. Imagine the towering skyscrapers that pierce the clouds in our modern cities. These aren't just static monuments of steel and glass. They're complex structures constantly battling the subtle tremors of the Earth. Instead of air, some of these buildings have massive dampers filled with liquid, strategically placed to counteract movement. When the building sways, these dampers push against the internal liquid. While the liquid's movement might seem minimal, it plays a crucial role, absorbing a portion of the shaking and preventing catastrophic failure. When constructing these colossal skyscrapers, engineers strive for simplicity and balance. Ideally, each floor maintains the same height, with support columns distributed evenly. However, architects often dream of more, envisioning innovative designs that push the boundaries of conventional construction. This is where compromise becomes essential. Take, for instance, the Tokyo Skytree, a futuristic marvel and one of the world's tallest structures. It incorporates a central pillar, reminiscent of traditional Japanese pagodas, alongside advanced seismic dampers. These dampers work tirelessly to absorb the energy unleashed during an earthquake, ensuring the building's safety and stability. Now, imagine an earthquake of unimaginable magnitude, a 15 on the scale. Such a cataclysmic event would possess the potential to obliterate our planet, vaporizing all water in mere seconds, leaving Earth a desolate, uninhabitable wasteland. Thankfully, such events are beyond our current experience. While over 500,000 earthquakes occur annually, none have reached this terrifying magnitude. A staggering 90% of these seismic events occur within the infamous Ring of Fire, a zone encircling the Pacific Ocean. The ground in this region is notoriously unstable, constantly trembling and shifting like a bowl of jello. The most powerful earthquake ever recorded reached a magnitude of 9.5. This immense power can actually alter the Earth's rotation, subtly changing the length of our day. In fact, even within the confines of your own home, minor earthquakes are constantly occurring, triggered by something as insignificant as a speck of dust landing on a table, registering at a minuscule 5 magnitude. Earthquakes are the result of tectonic plates in constant motion. These massive plates, akin to poorly secured Lego bricks, grind against each other, moving up, down, and colliding. This movement transmits to the ground above, unleashing the phenomenon we know as earthquakes. This tectonic activity acts like a massive battery, storing energy for centuries, sometimes up to 500 years. When this stored energy is abruptly released, the consequences are horrifying. Even the strongest structures succumb to this relentless force, leaving behind a trail of devastation. In some instances, these earthquakes can even trigger tsunamis, amplifying the ensuing chaos. Such immense power can split the very ground beneath our feet, causing widespread and severe damage. The strength of an earthquake was traditionally measured using the Richter scale, but it is now being superseded by the moment magnitude scale. When earthquakes strike, we hear reports of their strength, typically ranging from 1 to 10. Fortunately, we have yet to experience an earthquake that maxes out the Richter scale. The most powerful earthquake in recorded history struck Chile in the 1960s, registering a staggering 9.5 on the Richter scale. This event not only altered Earth's rotation, shortening the day by approximately 2 milliseconds, but also triggered a massive tsunami, impacting a vast area spanning 155,000 square miles. While the Richter scale technically has no upper limit, anything exceeding a magnitude of 25 is considered immeasurable. Should such an event occur, the planet would likely be reduced to dust, rendering any measurement irrelevant. As previously mentioned, the strongest recorded earthquake reached a magnitude of 9.5. Imagine if this event had been just 0.5 stronger. It would have created a rupture line stretching an astonishing 2,074 miles, nearly 7 times the length of Wyoming. A magnitude 11 earthquake would cleave a crack halfway around the world. Massive tsunamis would engulf coastal areas, obliterating everything in their path. Earth would plunge into a severe environmental crisis. For those who enjoy hiking, the event would create new mountain ranges born from the Earth's violent upheaval. Even the temperature would surge due to volcanic eruptions and the release of greenhouse gases, transforming our planet into a scorching oven. The safest havens would be far from buildings, coastlines, and mountains, in areas with a low risk of landslides. Countries ill-prepared for such a disaster would be utterly devastated, their cities reduced to piles of rubble and dust. Ascending the Richter scale would only intensify the devastation, but thankfully, an earthquake of that magnitude is deemed impossible. Earth's crust simply lacks the energy required to produce such cataclysmic events. However, there exists a force with even greater destructive potential: asteroids. These celestial bodies possess the power to obliterate our planet, as evidenced by the dinosaur extinction event. The asteroid that struck Earth millions of years ago, marking the end of the Cretaceous period, was approximately 6 miles in diameter. It triggered earthquakes that relentlessly shook the ground for months. These terrifying tremors were an estimated 50,000 times stronger than the Chilean earthquake. The impact also unleashed a tsunami 30,000 times more powerful than the devastating Indian Ocean tsunami. The resulting earthquakes from the asteroid impact are estimated to have reached a magnitude of 13. Imagine a cataclysm of unimaginable force, a natural disaster so immense, so devastating, that it dwarfs even the most terrifying events in recorded history. We're talking about an asteroid impact, a cosmic collision that unleashed a tsunami unlike anything our planet has ever witnessed. The Indian Ocean tsunami, a tragedy that impacted specific regions, pales in comparison. This asteroid-induced mega-tsunami would have engulfed the entire globe, sending waves towering over 3,300 feet high, crashing onto every coastline. There would be nowhere to escape this watery Grim Reaper, no matter how remote your location. Now, picture an earthquake. But not just any earthquake. Forget the Richter scale as you know it. A magnitude 15 earthquake isn't just a little stronger than the infamous Chile earthquake. It's a staggering 100 million times more powerful than a magnitude 9.5 quake. Such a seismic event could boil away Earth's oceans, leaving a desolate, lifeless husk. Ecosystems would collapse, food chains would shatter, and only the most resilient bacteria might cling to existence. The very notion is almost beyond comprehension, yet it represents only a fraction of the potential horrors. The ocean, our planet's natural air conditioner, would be gone. Without its cooling influence and its protective shield against the sun's intense radiation, Earth would become a scorching inferno. But even more terrifying is the potential disintegration of Earth's crust under the relentless shaking. If, by some miracle, our planet survived this unimaginable stress, the ground beneath our feet would liquefy, transforming into a gelatinous mass that shifts and undulates without warning. Buildings would crumble, civilizations would be reduced to rubble, and we'd be thrust back into a prehistoric age. We can see echoes of this destructive power in the tectonic movements that reshaped Japan, where plates lurched 165 feet before snapping back, triggering a devastating earthquake. No corner of our world is entirely immune to this bone-chilling phenomenon, although some regions face a greater risk than others. Consider the Ring of Fire, a horseshoe-shaped zone encircling the Pacific Ocean, where approximately 90% of the world's earthquakes occur. Here, tectonic plates grind against each other, creating an environment of constant instability. But that's not all. A staggering 75% of the world's active volcanoes and 90% of its dormant volcanoes are clustered within this volatile zone, making it an exceptionally dangerous place. Scientists diligently monitor this region, hoping to unlock the secrets of earthquake prediction. But the Ring of Fire isn't the only earthquake hotspot. In California, along the infamous San Andreas Fault, two massive tectonic plates have been accumulating stress for over 2 centuries. This 715-mile-long fault line holds the potential for a catastrophic earthquake, a chilling reminder of the devastation that struck San Francisco in 1906, a quake that registered 7.8 on the Richter scale. Experts warn that the probability of a magnitude 6.7 earthquake in the region is alarmingly high. Should the ground begin to tremble, remember the crucial survival advice. Drop, cover, and hold on. Seek shelter under a sturdy table or desk, shielding yourself from falling debris like windows, cabinets, and unstable ceilings. Remain in your protective position for a minute or two after the shaking stops, guarding against potential aftershocks. And be vigilant for the smell of gas. If you detect it, avoid any action that could create a spark, such as turning on lights. Consider the earthquake that began in Indonesia in 1829 and continued for a staggering 32 years, reaching its climax in 1861 with a magnitude of approximately 8.5. This prolonged seismic event was caused by the gradual collision of tectonic plates beneath the island. By analyzing the coral formations in the area, researchers discovered that the land had been slowly rising and falling over time, a phenomenon known as a slow slip event. In the midst of these geological forces, even a single bolt of lightning possesses immense power. It can instantly heat the air to a scorching 54,000 degrees Fahrenheit, creating a rapid expansion that generates a shock wave, the thunder that reverberates through the sky. To put our place in nature into perspective, consider that there are approximately 3 trillion trees on Earth, roughly 422 trees for every person. Before the rise of humanity, that number was closer to 6 trillion. Our planet is also dominated by water, with nearly 70% of its surface covered by an average depth of 2.5 miles. Beneath these vast oceans lie 97% of Earth's volcanoes, as well as the mid-ocean ridge, a colossal mountain range stretching over 40,000 miles. And even in our modern search for precious materials, humanity has mined an estimated 190,000 tons of gold from the planet. Experts believe that roughly 20% remains, waiting to be discovered. Let's journey to the heart of our planet, a world of incredible extremes. Picture this, the world's most active volcano, a colossal giant named Mauna Loa in Hawaii. Rising over 2.5 miles above sea level, its true scale is hidden beneath the waves. Imagine, if you will, the entire volcano stretching a staggering 11 miles from its base. That's the equivalent of more than 160 football fields laid end to end. Now let's talk about heat. The highest temperature ever recorded on our planet was a scorching 136 degrees Fahrenheit. This blistering heat was measured in Al-Azizia, in modern-day Libya, back on September 13, 1922. A stark contrast awaits us at the other end of the spectrum. The coldest temperature ever registered plummeted to a bone-chilling 129 degrees Fahrenheit, recorded at Russia's Vostok station in 1983. A truly brutal extreme. Earth, our home, is the fifth largest planet in our solar system, dwarfed only by the gas giants Jupiter, Saturn, Uranus, and Neptune. With a circumference of roughly 25,000 miles, it would take an average person approximately 8,300 hours to walk all the way around it. A journey made nearly impossible, of course, by the vast oceans separating the continents. Our yearly calendar marks the passage of time as Earth orbits the Sun. This journey takes 365.25 days. To account for that extra quarter of a day, we add a leap day every 4 years. Consider Russia, the largest country on Earth, encompassing a staggering 6.5 million square miles. This vast expanse covers more than 1/8 of our planet's inhabited land area. Yet, despite its immense size, Russia's population remains relatively small. Among all the planets in our solar system, Earth stands alone in having just one moon. Mercury and Venus have none, while every other planet boasts 2 or more. The age of the Earth is almost incomprehensible. Scientists estimate our planet to be over 4.5 billion years old. They arrive at this figure by studying the oldest rocks found on Earth, as well as meteorites that have crashed onto its surface. These meteorites are invaluable because they formed at the same time as Earth during the solar system's creation. The very ground beneath our feet is constantly being recycled. The planet's rock cycle transforms igneous rocks into sedimentary rocks, then metamorphoses those into metamorphic rocks before starting the process all over again. An endless cycle of creation and transformation. Our moon, so seemingly serene, experiences its own seismic activity, lunar earthquakes. These moonquakes are less frequent and intense than those on Earth, and are primarily caused by tidal stresses. The gravitational dance between the Earth and the Moon. Antarctica, the fifth largest continent, is a frozen world that holds a staggering 70% of the planet's fresh water and about 90% of its ice. A truly vital yet fragile reservoir. Bangkok is a magnet for travelers, earning the title of the world's most visited city, with a staggering 23 million visitors in 2019 alone. Paris, London, Dubai, and Singapore round out the top 5, each offering its unique allure. The lowest layer of Earth's atmosphere, the troposphere, is responsible for the weather that shapes our lives. Sunlight warms the planet's surface, causing warm air to rise into the troposphere. As this air rises, it expands and cools due to decreasing air pressure, eventually sinking back down to be warmed again by the Earth's surface. A constant cycle of heating and cooling. Coral reefs, vibrant and teeming with life, are the largest living structures on Earth. Some are so vast that they can even be seen from space. These underwater cities support more species per area than any other ecosystem on our planet, even surpassing the biodiversity of rainforests. The name Earth has Germanic origins, dating back approximately 1,000 years, and simply means the ground. Curiously, no one knows for certain who first coined the name. Earth is also unique in that it is the only planet not named after a Greek or Roman deity. The deepest point in the ocean, the Mariana Trench, plunges to a staggering 7 miles below sea level. Imagine the crushing pressure and the alien life forms that exist in that dark abyss. Coastlines, the dynamic meeting point of land and sea, make up about 20% of the land in the United States, yet they are home to more than 50% of the U.S. population. A testament to the allure and importance of coastal regions. Earth isn't a perfect sphere. It's more like a slightly squashed ball, bulging at the equator. This bulge is caused by the centrifugal force of the Earth's rotation, which flattens the North and South poles. The Earth spins on its axis, an imaginary line running through the North and South poles. This rotation is what gives us day and night. Our planet experiences seasons because its axis is tilted. This tilt causes the sun's rays to strike different parts of the planet more directly at different times of the year, resulting in the cyclical changes we know as spring, summer, autumn, and winter. To grasp the immense scale of our solar system, imagine the sun reduced to the size of a standard door. In this scale, the Earth would be about the size of a nickel. The Earth's rotation is gradually slowing down, an imperceptible change happening over vast stretches of time. It would take as much as 140 million years for the length of a day to increase to 25 hours. The Antarctic blue whale, Balænoptera musculus ssp intermedia, the largest animal on Earth, can reach lengths of 100 feet and weigh up to 400,000 pounds, roughly the same as 33 elephants. Imagine the sheer power and majesty of such a creature. The temperature at the center of the Earth is almost as hot as the surface of the sun, reaching a scorching 10,000 degrees Fahrenheit. A fiery inferno contained within our planet. Earth is approximately 4.5 billion years old, while humans have only been around for at most 450,000 years. A tiny sliver of time in the grand scheme of things. There are approximately 34,000 known species of fish swimming in our oceans, but the actual number is likely far higher. A staggering 95% of our oceans remain unexplored, holding countless secrets and undiscovered life forms. Route 66, America's iconic highway, is longer than the distance to the Earth's core. The distance to the Earth's core is roughly 2,000 miles. Imagine our planet, a colossal sphere spanning nearly 2,500 miles. This Earth, our home, is a complex structure composed of three primary layers: the crust, the mantle, and the core. The core itself is further divided into the liquid outer core and the solid inner core. Scientists, in their tireless exploration, estimate that roughly 8.7 million species inhabit our planet. Within this vast number, approximately 1 to 2 million are classified as animals. However, a staggering 86% of land species and 91% of marine life remain undiscovered by humankind. Let's journey back in time. For nearly 2 millennia, ancient astronomers held the belief that Earth was the center of the universe. They envisioned a static Earth, with all other celestial bodies dutifully orbiting around it. It wasn't until 1543 that Nicholas Copernicus revolutionized our understanding with his heliocentric model, placing the Sun at the center of our solar system. Earth holds another distinction. It is the densest planet in our solar system. While density varies across its different layers, the average density is just over 3 ounces per cubic inch. Consider the towering majesty of Mount Everest. Its summit marks the highest point on Earth, reaching an altitude of approximately 5.5 miles above sea level. Each year, an astounding 1 septillion, that's a trillion crystals of snow, descend upon our planet, blanketing approximately 31% of Earth's land area. Now, let's consider water. Of all the water on Earth, only about 3% is fresh water. The remaining 97% is salt water. Of that precious 3% fresh water, approximately 2% is locked away in ice and glaciers, leaving less than 1% available in lakes, rivers, and underground reservoirs. The Caspian Sea, a vast inland body of water, is the world's largest lake. It covers an area of approximately 140,000 square miles. But it's dwarfed in depth by Lake Baikal in Russia, the world's deepest lake, plunging to an incredible 5,300 feet. Our atmosphere, the very air we breathe, is composed primarily of nitrogen, roughly 78%, and oxygen, about 21%, along with trace amounts of water vapor, carbon dioxide, and other gases. No other planet in our solar system is believed to possess such a high concentration of oxygen, a critical element for life as we know it. This unique atmospheric composition may explain why Earth remains the only planet where life has been discovered. Beyond our moon, Earth has companions. There are 2 asteroids sharing our orbit. One of these, 3753 Cruithna, appears to follow Earth in its orbit, but in reality, it traces its own path around the Sun. Another asteroid, 2002 829, follows a horseshoe-shaped orbit around Earth, bringing it close to our planet every 95 years. Imagine this scenario. You are hosting friends for dinner. You set your drink on the counter and step away to assist with dessert. Upon your return, you notice the liquid in your glass sloshing violently, the ice cubes tossed about like ships on a stormy sea. A tremor runs through the floor. The chandelier above swings wildly. A scream pierces the air. An earthquake! The house begins to rock violently. You struggle to maintain your balance. Cabinets burst open. sending glasses and dishes crashing to the floor. Bookshelves topple, and everything hanging on the walls plummets to the ground. You dive under the dining room table, desperately trying to avoid the falling debris. You've experienced earthquakes before, but nothing of this magnitude. Checking your phone, you find the dreaded no signal message. Suddenly, with a deafening roar, the entire house collapses. The most powerful earthquake ever recorded struck Chile in 1960. The disaster unfolded in the afternoon, catching residents off guard. An earthquake needs to reach a magnitude of around 7.0 on the Richter scale to inflict serious damage. This one registered a staggering 9.5. This region of Chile sits squarely on the Ring of Fire, the most volcanically and seismically active zone on Earth, encircling the Pacific Ocean. The initial shaking lasted a terrifying 10 minutes. For 2 days afterward, powerful aftershocks continued to rattle the region, even triggering a volcanic eruption in the south. But the devastation didn't end there. The earthquake unleashed a series of monstrous tidal waves that surged across the Pacific Ocean, some reaching heights of over 80 feet. The earthquake and tsunami caused widespread destruction across the Pacific, impacting Hawaii, Japan, and the Philippines. The disaster resulted in approximately $500 million in damages in 1960 dollars. Countless people were left homeless, their infrastructure shattered. Buildings lay in ruins, and debris choked the landscape. Scientists estimate that the earthquake was so powerful that it shifted Earth's axis, shortening our days by 1.26 microseconds. While that may seem insignificant, consider the immense force required to alter the very rotation of our planet. Coastal cities were decimated, and flooding was rampant. The economy plunged into turmoil. Studies suggest that if an earthquake of this magnitude were to strike today, it could cause over $20 billion in damages. But what if an earthquake twice as powerful were to strike without warning? The effects would be felt across the globe. Tidal waves wouldn't just devastate the coasts of Japan and the Philippines, they would spread even further. Imagine, millions of years ago, a colossal asteroid, miles wide, hurtling through space. It slams into the Earth with unimaginable force. The immediate devastation is beyond comprehension, but the effects ripple outwards, triggering a chain reaction of catastrophic events. Let's focus on the tsunamis. These aren't your average waves. We're talking about walls of water hundreds of feet high. These monstrous waves would surge outwards, not just locally, but across entire oceans. They would crash into coastlines thousands of miles away, reaching China, Korea, Vietnam, and even Australia. And these aren't just big waves, they are terrifying. Imagine waves significantly higher than 80 feet, perhaps double that. That's like 40 giraffes stacked on top of each other, surfing towards you with relentless speed and power. If you live by the coast during this cataclysmic event, you might notice the water receding dramatically, pulling back further than you've ever seen. You could practically see where the fish make their homes in the deepest parts of the ocean. This is your warning. It's time to run. A tsunami of unimaginable scale is heading your way. Say it happens. You're caught in the initial wave, tossed beneath the wreckage of your home, disoriented and terrified. Somehow, you manage to fight your way free, bursting to the surface for a desperate gasp of fresh air. But you're not alone in your struggle. All around you, the houses in your neighborhood have been reduced to piles of bricks and rubble. Bridges have collapsed, leaving survivors stranded. You look around, dazed, and try to find help. Fire trucks and ambulances struggle to navigate the landscape of broken cars and debris. You try to reach your car, but the aftershocks are still hitting, throwing you to the ground. Cell towers are down, leaving you unable to call for help. Despite the chaos, you push forward, driven by the primal instinct to survive. You finally reach your car, only to find it crushed under a massive boulder, looking like a discarded soda can. You continue on foot, making your way towards downtown. The scene is apocalyptic. It looks as if some enraged giant has swept through the city, toppling buildings like toys. You push forward, desperate to find any sign of rescue. Suddenly, your phone vibrates. A flood of notifications about a magnitude 20 earthquake. The ground is still shaking, but for now, it seems to have subsided. But then you hear it. A distant rumble, growing louder with each passing second. You turn to your right and see them. Tidal waves as tall as skyscrapers, charging towards you with unstoppable force. Paralyzed by shock, you struggle to comprehend the scale of the disaster. Then, your survival instincts kick in. You run, not knowing where to go. Behind you, the tsunami relentlessly pursues you. In front of you, the city lies in ruins, with rocks and concrete still falling from shattered buildings. But there, a building, miraculously, still stands. It's your only hope. You race towards it, reaching the elevator only to find it jammed. No surprise there. You bolt up the stairs, tripping on broken glass and plaster, adrenaline fueling your desperate climb. You glance out a window and see the water, impossibly close. You're almost at the top, just a few more flights. Then, with a deafening roar, the water bursts into the building, dragging you down 2 floors. You can barely see anything, but you know you must swim upwards. The water fights you, relentlessly pushing you down. After what feels like an eternity, you manage to break free and continue your desperate climb to the top. You scramble onto the roof, collapsing in exhaustion, safe for now. The tidal wave rages on, tearing through the ravaged city center. Your phone is waterlogged and useless, but you have a horrifying 360-degree view of your town, submerged in water and debris. The ground begins to shake again. Perhaps you should just sit here and wait for it all to end. Wait for a rescue helicopter that may never come. Then, a deafening explosion rips through the air, shaking the ground even more violently. In the distance, smoke billows into the sky, soon obscuring the sun. Darkness descends and you see it. Lava shooting into the air like fiery fountains, landing nearby. The lava spreads, forming a river of molten rock, flowing through the town block by block. With this much seismic activity, the Earth's tectonic plates have shifted, unleashing magma from the planet's core. Steam vents erupt from the ground, followed by an unbearable wave of heat. You watch in horror as the magma covers everything in its path, consuming cars and melting the foundations of the few buildings that survived the earthquake and tsunami. Buildings in the distance begin to sink and collapse into the raging lava pool that has replaced your town. One by one, every building succumbs. And then you realize the building you're standing on is starting to sway. It's about to fail. But then, a glimmer of hope. You look up and see a helicopter in the distance. You wave your arms, run around, jump, doing anything to get noticed. It works. The helicopter circles, then drops a rope ladder. As you're lifted into the helicopter, you take one last look at the world below. The earth writhes and contorts like noodles in a strainer. You land a few miles away and are immediately treated by a doctor at an emergency triage center. You were one of the lucky ones. A year later, the tsunami waters have receded and the lava has cooled. But the magma has permanently altered the landscape. The town is gone, erased from the map. The disaster has plunged the entire country into a financial crisis that will last for decades. It will take months just to survey the damage. Imagine a scene, returning to a town ravaged by disaster. The storm has passed, but the aftermath lingers. Perhaps you're overseeing the rebuilding effort, ensuring no exposed electrical wires or fractured gas lines threaten the returning residents. In some communities, the decision is made to relocate, constructing a new town further inland, away from the reach of future calamities. In others, they choose to rebuild directly upon the ruins, a testament to resilience. Still others make the difficult decision to move everyone to a safer nearby city. For centuries across the globe, people have reported hearing mysterious, booming sounds with no apparent source. These are the so-called skyquakes, and yes, they are a documented phenomenon. If you've ever experienced a deep, resonant boom in the distance, one that defied explanation by thunder or a vehicle backfiring, you might have witnessed a skyquake. These events are reported worldwide, from the United States to India and Japan, each region assigning its own unique name to the phenomenon. The precise cause remains elusive. Intriguingly, these booms sometimes coincide with earthquakes. During the infamous New Madrid earthquakes of the early 19th century, these sounds were frequently reported. As recently as January 2020, eyewitness accounts described skyquakes as a rushing or rolling sound. The celebrated American author, James Fenimore Cooper, poetically characterized it as the lake speaking to the surrounding hills, which send back the echoes of its voice in accurate reply. At times, these enigmatic booms occur in cold weather, independent of seismic activity. One such skyquake hotspot is near Seneca Lake in New York, where they are known as the Seneca Guns. The booms can be so powerful that they rattle windows and doors. In the aftermath of the Charleston earthquake in August 1886, similar noises persisted for weeks, coinciding with numerous aftershocks. In 2020, scientists from the University of North Carolina delved into historical news archives, particularly those from North Carolina, where skyquake reports are frequent. Their aim was to correlate the sounds with earthquake data, but no connection could be established. One researcher suggested that the noises originate in the atmosphere, not underground. The team then investigated infrasound, low-frequency noises imperceptible to human hearing. They detected signals lasting between 1 and 10 seconds, coinciding with reported skyquake events, but definitive answers remain elusive. Speculations abound. Some theorize that solar flares, underwater tsunamis, or the collapse of subterranean caves beneath the sea are responsible. Others attribute the sounds to sonic booms generated by aircraft, a theory that fails to account for historical records predating the invention of airplanes. One intriguing hypothesis suggests that a type of meteor known as a bull light causes these booms, exploding upon entry into Earth's atmosphere. If such an event occurred above dense cloud cover, the sound would be amplified and travel great distances, leaving no trace on the ground. Another theory posits that gas escaping from the depths of deep lakes, like Seneca Lake, could be the source. If skyquakes strike you as peculiar, consider fog bows. Also known as white rainbows, ghost rainbows, or cloud bows, these atmospheric phenomena form similarly to their colorful counterparts, but exhibit distinct characteristics. Rainbows are born from large raindrops, always appearing opposite the sun. Fog bows, however, are created by minuscule water droplets within fog or clouds, also positioned opposite the sun. To witness a fog bow, one must seek out a thin fog under bright sunlight. The phenomenon might be observed as the sun pierces through the fog or near the ocean, where fog formation is common. Due to the minute size of the water droplets, fog bows lack the vibrant colors of rainbows, often appearing entirely white or exhibiting only faint hues. They can be difficult to discern initially, blending seamlessly into the mist, but once identified, they are unmistakable. Another rare weather event to watch for is thundersnow. As the name implies, it is a unique type of thunderstorm that occurs during a snowstorm. Unlike regular thunderstorms, which are prevalent in spring and summer, thundersnow is considerably rarer, manifesting during the most intense winter storms, such as blizzards. It requires the simultaneous presence of warm air, a relatively uncommon combination. For thundersnow to occur, there must be moisture in the air, a degree of instability, and a lifting mechanism, such as rising winds, similar to conventional thunderstorms. Lightning can occur, though it typically flashes from cloud to cloud rather than striking the ground. The thunder itself sounds different, resembling a low rumble rather than a sharp boom, as the snow muffles the sound. While the risk of being struck by lightning is reduced, it remains prudent to seek shelter indoors upon hearing thunder. And now, something for Northern Lights fans.